Or five, most of the people there are going to stick around till the end. So if you've got this far, the things look pretty good for you statistically, so well done. This week, we're going to be looking at collisions, okay? And we're going to, just as we did things a little bit differently with our animation, we're going to do things slightly differently with our collisions. We are going to use a tile collision system this time around. I know I've sung the benefits of doing tile-based collision before in the past, but I will say that it's arguable, depending on the type of game you're doing, whether there really is that much benefit to doing like a tile-based system over an object-based system. But I've never shown how to do a tile-based system in a game before, in a full project anyway. I thought it would be good to cover that in this series. We're actually going to do a combination of both for colliding with different things. But since the bulk of what we're going to be colliding with in the game is just like our background scenery, like our walls and houses and rocks and stuff like that, things that are static and unchanging in the environment, I think it makes a decent amount of sense to use a tile-based system. And for our player is only going to collide with these tiles based on a single pixel, just that bottom, just their origin point. Just this point here is basically going to be what our player is to the game world in terms of the tiles that we place. We'll use the collision mask that we created for colliding with other entities and things like that that are more specific and make more sense, I think, to work as collisions between different objects and instances, because there'll be less of them to actually calculate the collisions between. And for the rest of the world, we're just going to use a super fast system to check the collisions between just this single point on our feet, our bottom center of our player, and a tile grid. Okay, just makes things super cheap, super efficient, and easy to look after. So we're going to get started as we usually do by adding a sprite of some kind. It seems to be how we start a lot of our episodes. So I'm just going to close everything down, and I'm going to press Alt-S and bring in a new sprite. I'm going to call it S-Col. Okay, col being short for collision, and I just do that because I get sick of writing the word collision over and over again, so I just call it col. Gonna go to import. We've got our assets here. I'm gonna pick scol.png if you're using the assets available with this series. It's really not that much. I could have just made a new one, really. 32 by 32 sprite. Split into like 16 by 16 squares with just a 16 by 16 transparent red square in the top right corner is exactly 16 pixels though, like this here. You can see like selection. You can see like the bottom there, selection area 16 by 16. Okay. So make sure it is, because we're going to split this into a tile set. I didn't actually need this space down the bottom here, but I thought it helped just for the sake of clarity. Okay, so you can recreate something like this very quickly if you want to. It's really not that difficult. Or you can turn this grid on as well up here to help you with stuff like this when you're making tile sets. And set the grid size to be whatever you want, set the color to be whatever you want, and so on. That's quite handy as well. But as you can see up here, in the top right, 16 by 16 square. You might be wondering, why have I done this in the top right of a little grid? Why isn't it just a single sprite by itself? When you make, well, rather than explain it now, I'll show you. I'm going to make a tile set next. Okay, so I'm going to go to tile sets, right click, hit create tile set, or just create it in a myriad of different ways that you can use the interface to create a tile set. However you want, you'll end up with this. And I'm going to call it tcol. Okay, and in sprite, I'm going to assign the sprite to scol. Okay, and I'm just using the middle mouse to drag around this, and then control and the mouse wheel just to zoom right in. Or you can press this as well. Oh, okay, I thought that would zoom to fit. Oh no, center fit, that's the one I want. There we go. Just to zoom in on it. And you'll notice like it's split into 3 here. I don't know if this is the default or if I've changed the default. It might be on something like 32 by 32. If it is, just make sure tile width and tile height are 16. Like 16, and you'll see this grid appear. And you'll notice that there is no square on the top left. And whenever you make a tile set, it is important to leave a tile blank in the top left of the image. Okay, that you're going to split into tiles. And this is why I couldn't just make this a 16 by 16 square, because you need the first tile of whatever your tile set is to be blank. I don't know all the specifics of why. It's an internal thing to do with how tile sets are handled, and they use this space to store some information, I think, about I don't know. All I know is it needs to be blank. Okay, it needs to be blank and transparent. Or rather, it doesn't actually, like, you can put stuff in here if you want. It just it won't matter. Like, that's not a valid tile. Okay, so when we actually come to placing this tile around the tile set around our room editor, we won't be able to place this tile. So you may as well leave it blank, because it's not going to do anything. Okay, so just make sure all the tiles you actually want to use are not in the top left. As I say, I could have made it this size or whatever, right? I didn't need these two at the bottom. I just thought that helped make it. I don't know. I just thought it was clearer somehow. Alright, don't judge me. Alright, so this is our tile set, and all we're going to use it for is to mark which areas of the game world we want to be collidable and which areas we don't. We haven't actually brought in any of our background art yet, but it's all going to be 16 by 16 tiles. Okay, so let's just mark that out very easily. So if we come to room 0 now, I'm just going to zoom out a bit there with control mouse wheel, and in the layers over here, I'm going to add a tile layer. Okay. Just like split into a little grid icon with create new tile layer as its tooltip. Click that, we'll get a new layer. I'm going to click it, press F2 just to rename it col. Okay, just we'll have a layer called col, and it's just going to be the same layer that we use in every room just to define our collidable areas. Where it says no tile set here in layer properties, click that, select tcol to assign the tile set that we want to use, and you can see it's automatically adjusted to give us a 16 by 16 grid. Now, assuming you have grid turned on in the room editor, and we've got this tile library, selector, whatever you want to call it. And as you can see in the top left, we've got this weird checkerboard one here. That's just like a null sprite, right? So that's, I say, you can't use the top left with a tile set. Anyway, click our red transparent rectangle, and I'm just going to draw a world, I guess. Eventually, we'll make this layer invisible when we actually bring in some of our background art, but for now, just paint some stuff around the place, okay, or whatever you want, just so we have a world to walk around and we can test that the collisions are working. Alright, so with that in place, let's get to work actually making this work. So go ahead and close room 0, come to O player, go to the create event, and right at the top here, I'm going to put a line in to get the ID of that layer, okay, because we're going to need it. I'm going to type collision map equals layer underscore tile map underscore get underscore ID. Okay, basically that's going to reach into a particular layer that we have in the room and find the ID of the tile map that is on that layer, assuming there is a tile map on that particular layer. But to do that, we need to give it a layer ID, first of all. Just to be clear here, I'm going, there's a layer called, and then the tile map on that layer. We're trying to get the ID of the tile map. So we need to first of all tell it which layer we're trying to find the tile map of. That's what I do. So inside the bracket layer tile map get ID, I want to type layer, get ID, open bracket, the big mark, call,
quotation mark, close bracket, semicolon. Alright, that's the full line. We just provide the name as a string here, in the layer ID, that's the ID of the layer we're looking for, and then we find the tile map on that layer, and we store it in collision map. And that's what we're going to check against when we're looking for collisions. Let's maximize this when we're working with a bunch of code. So, maximize that, right click, go to add/open event, go back to our step event, where we have all of our lovely growing week by week logic for our player, and get rid of this section. Okay, this is where we were committing to our movement. Alright, so we worked out our inputs, we worked out the calculate where we want to move, and then we have to commit to the movement. Select that, click to white repeated, just delete it. Because what we are going to do with our collision, and you'll remember this kind of logic if you've done the platform series or anything like that, is we're going to look for a collision on a horizontal axis, and then commit to whatever horizontal movement we want to do as a result of that. Then check our vertical axis, and then move if we still want to move on that axis. Okay. So we're going to be doing the collisions before each particular movement commitment, if you will. So what I'm going to replace that with is a player collision. Open bracket, close bracket, semicolon, and that'll stay grey. Might even get like an error or whatever. So we're just going to put a script here, just as we did with player enemy sprite. We're going to make a script called player collision, and that's going to handle our collision. And the reason I'm putting this in the script is eventually we're going to make a state machine, and don't worry if you don't know what that is. But eventually we're going to need to reuse this code in various places, and it helps to not have to copy and paste it. So we're going to put it in a script. So right click in script, click create script, and make sure you name it exactly the same, otherwise obviously code won't work. So player collision. If I don't save that, come back to here. Reopen that, eventually it will, yeah, eventually, sorry, yellow again, to get that script up, and with that script up, the first thing we want to put in it is var underscore collision equal false. Again, this is something we're not going to use right away, but eventually some of our different states and other users of this script might want to return whether or not there was a collision and do something about it. It won't matter for our basic moving around, it's just not affect our movement speed that we're going to do in here. But it might matter later on in future episodes. So just get that in for now. In fact, at the bottom of the code, like return underscore collision. Okay, and then all that code is going to be in the middle here to basically determine whether or not there was a collision, and then the script will send back whether or not there was a collision. As I said, not important for this episode, but will be important later, so get it in. Okay, so the first thing we're going to do is check our horizontal axis. To make a comment, horizontal tiles. Okay, distinguished from horizontal entities that will be later in a different type of collision check. So just checking our tile map first one. If open bracket tile map underscore get underscore at underscore pixel. Open bracket. Collision map, that's the variable we stored the tile map ID in earlier. Then we just want to provide the coordinates of a particular pixel. I'm going to check that pixel on the tile map to see what tile is there. Okay, so x plus h speed, that's the position we are about to move to, right? And y is just y. Close bracket, close bracket. Now, this will actually return a bunch of info. If you've done things like add blends and rotates and stuff to your tiles, then doing this won't be enough. You'll have to then go ahead and get like a tile map get index from this data or something like that. I can't remember this, but since our tile map is very, very simple, and all we're doing is just placing this one tile around the room. Basically, the data we're going to get back is either going to be 0 for no tile or 1 for tile 1. If we were using like tiles 2 and 3 and so on and so forth, then obviously there'd be more data, like you could get a tile, you basically get the tile index back, right? But for us in this situation, we're either getting 0, which is no tile, or we're getting 1, right? Which is very handy, because then that means we can just do an if with this and get back 0 or 1, which is equivalent to true or false. So if this comes back as 1, then we know we've hit a red tile, and if it comes back as 0, then we haven't hit any tile, okay? So we know there's going to be whether or not there's a collision where we want to move horizontally. So assuming there is a collision where we want to move horizontally, what do we do in here as a result? We do x minus equal x mod 16, which is the size of our tile. In fact, I am going to make that a macro. So I'm going to write tile underscore size in all caps. Go to macros, and type hash macro tile underscore size 16. Okay, I'll turn red, whatever GameMaker, there we go, whatever GameMaker feels like it. Because that's going to be consistent, and if we ever want to change it, we'll just change it there. So come back to our script now. So what does it want? So for those of you who don't know, what mod does is it returns the remainder of a attempted division into whole numbers, right? So we can take x, see how many times tile size goes into it, and return whatever's left over. So if since tile size is 16, if our x was 18, 16 goes into 18 once with 2 left over, right? So it would return 2. What that basically means is it's going to put us at the very left of whatever tile we're currently in. Which makes sense if we are running to the left and we're about to hit a wall. We're on like pixel 2 of this particular tile in the grid here. So we're trying to move into this one. We don't want to, so we're going to move to the far left of this tile. You might be wondering, well, what if we're moving to the right? We're moving to the far right of this tile. And that's true. So what we want to do is say if sign, sign, open bracket, h speed, close bracket, equals 1, close bracket again. So if our h speed is positive, then we want to move to the far right of the tile instead. Okay, that's very easy to do. It doesn't matter that we've done this ahead of time anyway. We've done that, so we're at the far left of the tile, regardless, but if we were moving to the right, we want to be the far right of the tile. So x plus equal tile size minus 1. Okay, so we want to move ourselves to pixel 0, or pixel 1, rather, of the tile. So we want to move to the very far right. If we added tile size entirely, we'd move to the first pixel of the next tile. Okay, so we want to move that amount minus 1. So we're going to move 15 pixels to the right after moving to the far left of the tile. We're just going to move all the way to the far right. Okay, so that guarantees us that we'll be on the very border of the tile. Okay, it's very handy. It's just super quick maths. Lets us just snap to the appropriate position. Whereas if we were colliding with objects, as you might remember the platform, we have to kind of do like a while loop and check every single pixel along the way and move as close as possible to it. But since we know exactly where our collisions will take place along a fixed grid, we can do very quick maths by dividing with the size of the tile to position ourselves perfectly. It's one of the biggest advantages of doing a tile map collision system. After that, we obviously want to reduce our horizontal speed to 0, so we don't want to move anywhere else this frame. So h speed equals 0. And set our collision to be true, because we know we can have a collision. So collision equals true. Then, once we've done that, so we check if there's a collision. If there is, snap to the correct side of the tile that we're on. Set our speed to be 0, so we then move into the next tile. Set collision to true, so we'll return true at the end of the script. Okay, that's everything we actually need to do as part of colliding horizontally with tiles. All we need to do, once we've done that collision stuff, is commit to our actual horizontal movement. So open a comment here and write horizontal move commit. And then just replace that line we copied over here, x plus equal h speed. And we're going to do the exact same thing underneath. So just select all this, copy, paste, store the bottom, make sure we don't accidentally change any of the good stuff. Change this to vertical tiles. Change this to vertical move commit. Remove the plus h speed from the end of x here, and put plus v speed on the end of the y here. Don't just change it around, that's a common mistake, at least a lot of problems, make sure you put it on the y. Change x minus equal x mod tile size to be y minus equal y mod tile size. In this case, I was going to put it at the very top of a frame. If sign h speed equals 1, no, if sign v speed equals 1, then y plus equal size minus 1. V speed equals 0, collision, v speed equals 0, collision equals true. And vertical movement is just to be plus equal v speed. So we just swap all those variables around. The only one you need to be careful of is up here, because like, it can be easy if you're just swapping the x's to y's and so on. To just do that up here, but you need to make sure you move it across from being where we put the x coordinate here, x plus h speed, being at the far end for y plus v speed here. Okay? Just be careful with that one. Then all we need to do is come back to our player's step event. I'm going to close that one a little bit there, here we go. Come back to player step event. And I was going to say put player collision in, but we already did that earlier. It's there waiting for us. That's everything then, that's everything we need to do. So I'm just going to press Ctrl S, because the save game, and press F5 and run. And what did I screw up? Variable oPlayer.v, not set before reading it. Yeah, v is definitely not a variable one here. Some of you will have spotted this in the video already, but we make these mistakes, mistakes happen. It's good to show what will happen if you make a mistake. So come back to player collision. And let's find where I should have looked in the area to see where I can make that mistake. But I can see now it's here. Vertical move commit. It's not v plus v speed. It's obviously y plus equal v speed. Okay. Mistakes happen. Okay. So I save that. Try running around again. Here we are. Running around the world. I run into the walls. I ran into them. Cool. You can see I'm kind of behind the wall at the moment. I guess we can quickly fix that. If it comes to room editor, just drag cold be underneath the instances. Eventually it's going to be invisible anyway. But just for now, just so you can kind of see how it works. You can see using it's just based on this one pixel that's our bottom center. I'm just aligned with these walls. I'll also just sort of appearing in front of them, with our sort of 3/4 top-down perspective. And it works pretty flawlessly, pixel perfect. Like, it's really easy to do this kind of collision system when you're just working with one pixel at a time. It's super cheap, super efficient. You could argue because we're only using fairly small rooms throughout this project, you're not going to run into a huge cost problem by using objects and entities for collisions if you prefer to do it that way. So I thought it was good to show off how you can very, very easily write a tile collision system for a game like this. And yeah, we're going to stick with it. Thanks everybody, hope you enjoyed part 3. Remember, if you want to get your hands on the source code, there's a link in the description that will show you how to do that. You could also, while you're in the video description, you could go visit my Patreon. That's cool.
Today, understanding and deriving meaningful insights from data is fast becoming the most needed skill.
Hello everybody and welcome to part 4. We're going to be doing something very important today in setting up a crucial piece of our game structure, which is our player state machine. Don't worry if you don't know what a state machine is or you've never heard that term before, it's a fairly straightforward concept. What we're going to do to set up and demonstrate that concept is create 2 states that our player can be in at any point in time. The first will be our free state, which is what the player is in now, actually, where they can move around, or they can be stood still. Okay, and that's basically it. And they can go from the free state to a number of other states. In this episode, we're going to create the roll state that we can move to. Okay, so whenever the player presses the action button, they enter a rolling state. They go for an animation, move a certain distance, and while they are doing that roll, while they are performing that roll, they will be executing a certain branch of code that they won't be executing while they're in the free state, where they'll be executing the code that lets them move around. It is an important code structure to be able to understand. It's what allows us to really do anything that's really complicated with the player character if you want to be able to climb ladders, talk to people, use items and all manner of different things without the code tying itself in knots, because we're able to keep each one of those states nice and distinct from one another. So in order to make our player roll, the first thing we want to do is bring in the animation for that roll. So I'm going to press Alt-S to make a new sprite. I'm going to call it S player roll. Hit import, and I believe it's called S player roll. And someone S player roll underscore script 24 is my sprite. Bring it in, set the origin to be bottom center, or positioning yourself on the sprite. 8x, 23y, I believe that's exactly the same as it. Is in S player, yeah, 23, just make sure it lines up. However, your own sprite and artwork work, or using mine, just use those numbers. The sprite itself is set up the same way all our sprites are, okay, with 4 directions in the same order. This one's 24 frames long for me. The main thing to understand about how I'm doing the roll is that each direction contains one complete roll. So you can see it starts in this kind of leaning down position, goes into a roll, and finishes about to return to the neutral position again, just that again, in each sort of direction. Okay, the reason for that is, the reason that is important is because the way we're going to animate this is slightly different. Instead of relying on whatever our frames per second here is, this is irrelevant to us. We want there to be one complete roll no matter how long the roll itself is in terms of physical distance. So that allows us to tweak it in just that distance and just the speed of the roll without worrying about the animation not matching up. So we want it to contain one complete roll no matter how long the roll itself is, so that if the roll is really long, the animation will take longer because it's slower to fit it all in, and if it's a really short roll, it'll animate for it really quickly. Okay, just to make sure that this one complete roll fits into the act of rolling itself, regardless of whatever numbers we set to match that. Okay, and then that makes it easier for us to, in general, once we've determined the best kind of roll distance and speed for our gameplay, to make the sprite and artwork itself fit. Okay, so that's all for our sprite. The next thing we want to do is add a few new things to the player create event. So we double click over player, click the create event, maximize this if we want. I'll make that a little bit bigger too. So we want to add, first of all, our new rolling sprite. So down here with our other sprites, I can add sprite roll equals S player roll, semicolon. And we want to add the speed and distance of our roll. So just under speed walk, just puts in the same place. I'll write speed roll equals, we'll make it 3.0, 1.5 times faster than our walking speed. And the distance that we want to roll in pixels. Distance roll equals 52. I don't know what the significance necessarily is of 52. It's like, I don't know, like 5 tiles or something like that, 4 tiles. I don't know, that's just a number I ended up settling on in my pre-production and decided, yes, this is the correct distance for this roll. You can experiment, change it about, use whatever you want, you'll see as we go through. Okay, there is one more thing we need to add to the create event, but before we do it, I'm going to create 2 new scripts. So right click the script and you hit create script, and call it player state 3. Then I'm going to make another one, and call it player state roll. And what we're going to do is, every game step, at the moment, we're just running whatever is in our player's step event, right? Running all this input stuff and working out where we're moving, and adjusting our sprite, and so on. What we're going to do is, instead, when we come into our step event, determine what state we're currently in, and run one of these scripts. There'll be a bunch. More reliable, like alternative player state, die, player state, hook, player state, talk, and all those different kinds of things as we go through the development of the game. But for now, we just have these 2 states, and we want to, instead of doing one giant chunk of code from the step event, either do the stuff we kind of have here now in our player state 3, or do just a generic kind of move in one direction kind of script in player state roll for when we're rolling. So first of all, with OPlayer open, go to your step event, we'll maximize that as well. And I'm just going to shrink this down just to make it clear so you can see it all at once. So this is our player's entire step event at the moment. What I want you to do is, underneath input magnitude, select everything beneath that, and press Control X or cut, whatever you're a Mac, I don't know what the shortcut is for cutting, but cut it, okay? So it's on the clipboard, but remove. And this here, the inputs, we're going to want our inputs no matter what state we're currently in, really. So we're going to leave this in the step event itself. But all of that code that we just cut, I want you to then go into player state free and paste it. Okay, so all of this stuff will only happen when we are in the free state. Okay, so movement based on our direction, the collisions, updating our sprite to either be running or standing, and then animating that sprite. Okay, all of that stuff is only going to happen when we're in the free state. How do we make that happen? Because all we've done is just put it into a script and actually calling that script in any way. Well, what we can do is, if we go back to the create event of the play by whatever it means, at the very, very top here, this is important, I'll put it at the top, I'm going to write state equals player state free. Semicolon. Now, I've written the name of the script here, but I'm not actually calling the script. Okay, if I just come back to this script here, you'll see where we called scripts before, things like player collision. Let's make it bigger again. Where I put player collision, open bracket, close bracket, semicolon, and that calls the player collision script, and player animate sprite, open bracket, close bracket, and that calls the player animate sprite script. But that's because I put these brackets at the end here. If you put these brackets here, or if you supplied arguments to a script, then GameMaker knows that you can call that script and actually execute its context. If you write it without the brackets, then you're not actually calling the script, you're just referring to that script itself. So if I now come back to our create event here, where I've written it without writing the brackets, all I've said is that state is going to equal a reference to that script. Okay? It's not going to call the script, it's not going to run the contents of that script, it's just referring to it, which allows us to then tell GameMaker later to execute whatever script is contained in this variable. Very, very useful. Okay? And what we can do is just swap that state between this script, player state free, and any of our other player state scripts. In this circumstance, that's just player state raw. Alright? So now that we've set that variable to be that script, how do we call it? Well, if we come back to the player step event, nearly one way to get that, I have it open here, so which is just currently our inputs. If I write script underscore execute, bottom of here, open bracket, we can then provide the name of the script, which is state, because we know the player state free is in state, and then any arguments we supply to that script. We don't have any arguments we supply to any of the scripts we've made so far, so I don't need to put those in, and I can just close the bracket there, semicolon. So because we know that all is contained in state is a reference to create player state free, and player state free just contains all the code that we had in the step event before, we can therefore conclude that if we run the game, we've got exactly the same game that we had before. Okay? Absolutely nothing has changed here in terms of how it works, but we've split it up so that all of this code is now contained in player state free, and we only want to run that when we are in the state that allows us to move around freely. So now what we need to do is make it so we can get from one state to another state. So underneath all of the stuff in our player state free script, we need something we can do in the free state to move us from the free state to the rolling state. And for now, that's going to be as simple as pressing a button. So I'll put a comment here for now, just says change state at the bottom. So we've done everything on a frame, and then right at the end of the frame, we're going to check to see if we've pressed the button or done some combination of things in the game that allow us to change state. For us, that's just going to be if key activates. You'll remember key activate from the step event of player. It's one of the keys we defined earlier as the spacebar. And what we're going to do is, if that key has been pressed, we're going to set state to equal player state. Oh, sorry, it's in the capital P. Player state roll. Semicolon. And also, move distance remaining is going to equal distance roll. Remember the value is set to 2. We're going to set the new variable to equal that value. And basically, we're going to reduce that value until it hits 0, and that's when we're going to stop rolling. But no, to start rolling, we have to set that to a high value, so we're going to set that to be 52. You'll see how that works in a minute. Close the bracket here, but that's all that's necessary, is to set state to equal player state roll, because then the next time the step event loops around, we get down here, script execute state, it's going to execute the roll state, which is currently blank, instead of the free state. So what do we think that will currently do? Since player state roll is currently totally blank, what that means is if we run the game, we're able to move around like it's normally, and then the moment we press the spacebar, the player just freezes, and he's unable to do anything else. Because we're still getting our inputs and everything, that's still happening in the step event, but then it's executing this script, which is completely blank, okay, and then therefore it's not never going to do anything else, not animating or doing anything. Okay? Alright, so the last thing we need to do now is just actually fill out the roll state with what we want to happen to enable us to actually roll. So the first thing I want to do is, similar to player state 3, is calculate where we want to move. Previously, in player state 3, that was based on whatever our input magnitude and input direction were. But since rolling is we just want to roll in one fixed direction, we don't want control over which direction we're rolling as we're rolling. We're going to assume that we've already set a direction by facing a particular direction before pressing the roll. So whatever direction we were in when we entered the state is going to be the direction that we continue to roll. So our movement is going to be a bit simpler. It's going to be h speed equals length the underscore x, and then we just provide a length in a direction, how much we want to move horizontally. That's speed roll, which we know is like 3.0 from here, and in the direction of direction, just whatever direction we're going to be in. And v speed is going to be the same, but also equals length to y, open bracket speed, roll, comma, direction. And that's it. Alright, so that's going to set us up for moving in a particular direction forever, right? So we have committed to moving ourselves yet. But what we want to do is make sure this movement speed eventually ends, and that's what our move distance remaining variable is about. So we have move distance remaining, again, and we're going to set it to equal max. Max is a function that returns the biggest of whichever values you put into it. So whatever is bigger out of 0, or move distance remaining minus speed roll, because we can assume we've moved speed roll amount in whatever direction. Okay, so we would move 3 to the right or whatever. So we're removing the distance we've just moved from however much we've got left to move. Okay, the reason we do a max with that rather than just subtracting it from it is we make sure that it definitely hits 0 and doesn't go to say -1 or whatever. I don't think that's really a problem here, but it's just decent practice to make sure of that. Then I'm going to write var underscore collided equals player collision, open bracket, close bracket, semicolon. That's going to call our collision script again, if you remember from the free state, but it's going to return the results of that collision into this temporary variable collided. You'll remember we set that up. If I go into a middle click on that, come into player collision, remember we set this variable at the top here, var collision will be false, and then collision true, and so on, and then it returns it. The return of underscore collision there will get put into underscore collided here, okay? So we know whether or not there was a collision, and it's going to put it into this variable. We didn't have a need for that in the player state, so we just call the script, and we don't care what it returns, it doesn't return it anyway. Then here I actually care about whether or not we collided. We won't for this particular episode, but I'm setting it up now. Basically what I'm going to have happen is when we do collide with the wall, eventually we're going to have like a bonk effect, okay? So we hit the wall and then we kind of bounce off of it. Not necessary right now, we're just going to stop moving when we hit a wall, but later we're going to want to know that. So that's why I've written it this way instead of just calling the script by itself. Next we're going to update our sprite according to how far into the roll we are. We're going to do it a bit differently to how we animate the sprite in 3 steps. Alright, update sprite. First of all, we know that the sprite index is going to equal sprite roll. Okay, that variable we set in the create event, it equals the name of the sprite. We know it's always going to be that because we're in the roll state. There's no other sprite we can ever possibly want that to be. Okay. Then var underscore total frames equals sprite underscore get underscore number sprite underscore index close bracket divided by 4. You'll remember that line, that's just telling us how many frames there are in a single direction worth of animation. But this next line is a bit different. This is why we're not just calling the player animated sprite script, we're doing it a bit differently. As I said before, we want to make sure there's only like one complete roll across the course of the animation. And in order to simplify this a little bit, I'm actually going to make a new macro called, so I'll go to macros here, I'll script, and then type hash macro cardinal underscore dir. And that's going to well, it's not, you haven't got equals from macro, but you'll remember in player animate sprite before we had this, var underscore cardinal direction equals round direction. But you'll remember in player animate sprite before we had this, var underscore cardinal direction equals round direction 90. I'm going to copy and paste, well, I'm going to copy this, round direction divided by 90, come back into macros, and paste that on the end of here without. Semicolon, remember. Because we're actually going to use this quite a lot throughout the game, and rather than just write this out every time and remember it when you need to every time, it's easier to just stick it in a macro, and then we can just write cardinal dir everywhere we need to use it. Interestingly, at the same time, if you go back to player animate sprite, I'm thinking now actually remove this line entirely and simply swap the one reference to it here, underscore cardinal direction, with that macro. We've got exactly the same purpose. It's just going to put this function here directly into where we put that there, okay? So now come back to player state roll. So to determine what frame we're actually going to show, we're going to write image underscore index equals open bracket cardinal dir, which if you remember is a number between 0 and 3 or 0 and 4 technically, determining which directional sprite we actually want to show, multiplied by underscore total frames. Okay, so that's going to put us at the start of a particular animation. It's either going to be frame 0 or frame 6, or frame 12, or frame 18, right? Then we simply need to add the number between 0 and 5, which tells us how far along in that particular animation we are. So plus, open bracket, 1, minus, open bracket, move distance remaining, divided by distance roll, close bracket, multiplied by underscore total frames, close bracket, semicolon. Let's shrink that down, that's quite a long line so you can see it all at once. So we know that move distance remaining is a number between 0 and 52, alright, depending how far along the roll we're at. Distance roll is 52 itself. So this here, move distance remaining divided by distance roll, simply tells us how far along the roll we are. Or rather, it tells us how much of the roll is left. Because 52 over 52 would be 1 or 100%, right, of the roll left to go. And like 1 out of 52 would be like a very small percentage, and 0 out of 52 would be 0 or 0%, right, of the roll left to go. So if we take that figure and subtract it from 1, what that gives us is the inverse. Okay, it tells us how far along the roll we actually are. Because 52 over 52 would be 100% of 1, so 1 minus 1 would be 0, with 0% along the roll. Half of that, 26 over 52, would be like 0.5, 1 minus 0.5 would be 0.5, 50%. Okay, and 0 over 52 would be 0, 1 minus 0, 100, right, 100% all the way through it. And then we just multiply that by the total frames, which is like 6, right, to give us the number of frames that we need to actually add onto and index from the first frame in whatever direction we are, to give us how far along the roll we should be. It's a very useful method if you want to determine your animation, if you want to make your animation fit the numbers in your game, the distances and speeds in the game, rather than trying to make the distances and speed in your game match whatever sprite you've animated, okay? Quite cool. Last of all, we just need to make it so we leave this state once the roll is actually finished, okay? So once move distance makes its way to 0, we can leave this state. So in the right comment, change state at the bottom here. I always tend to state changing stuff at the bottom of a particular state script. If move distance remaining less than or equal to 0, which we actually know it's going to be less than 0 to the next statement, but I just like to be extra safe because why not? Open bracket, close bracket, and in the middle here, like state equals player state free, semicolon. Remember, no open bracket, close bracket, we'll set it to equal the script, not for the script. Alright, that is our complete roll state. You'll see, obviously, we've got a warning here saying if we're not using underscore collided. Like I said, we don't use that later, so don't worry about that. I'm going to press F5 now. You can see we move around, and if I press the spacebar, we do a complete roll. You can see it finishes one completely with the animation because that's determined by how that set will fit, no matter how long or how fast the roll itself is. But it's handy because we can now go into OPlayer, go into the creator, and we can change these values around, and it won't cause our animation to screw up or not play all the frames and so on. So I can change this to be, say, 72. A bit of a longer roll distance. I'll space here, press space, you can see a nice long roll. It still plays the full complete animation in that direction. Okay, so one mistake I noticed at the end of the video there, and you might have noticed it as well if you have a particularly keen eye, is that this wasn't working quite right. So I've adjusted the frame rate to 15 just to sort of show you what the one problem we had was. You can see if I roll upwards here, did you spot it? The very, very last frame was slightly off. It was actually showing the first frame of the next direction in the sprite. And there's a lot of ways throughout making the game where this kind of error manages the conflict in different ways. So one of the slight annoyances of trying to do a system like this is handling it manually. You do have to account for a lot of sneaky edge cases you wouldn't otherwise. But you'll notice in every direction here, easy to notice if I roll against the wall because I'm stationary. The very last frame, it only happens for a split second. So the very last frame is wrong. The reason that is, if you're going to do player save hole here, is because the final destination of this being, 1 minus 0 here, so 100% times total frames actually puts us on the very next frame. So if we're on the next direction. So if we're here at 0, we've got 1, 2, 3, 4, 5, 6. There's the 6 total frames in here, right, in this direction. But if we go from frame 0, index 0, and we add 6, that puts us on index 1, index 2, index 3, index 4, index 5, index 6. See here? And it's only the very last frame because before that, if we're at 0.99 or whatever percent, if we're at 99% of the way through, we would still be on like frame 5.99 or whatever, right? Which still works out as this sprite. Because it's flawed, I think. So only for a single frame are we on this frame. Now we can't just subtract 1 because then we'd be the first frame or whatever as well. But the way we can fix this is to basically just make sure that value never actually goes above total frames minus 1. So it never goes in this case, above 5, alright? We can do that simply by using a min statement, similar to how we use the max one here, which returns the biggest of the two values. If we rack this around here, or this whole section here, because this tells us where we want to start, and then this is just a number between 0 and 6 currently. We want it to actually be a number between 0 and 5, alright? So we can just simply write min here, open another bracket, this whole equation, or comma, total frames, capital F, minus 1, close bracket. Alright, very simple fix. It might be even simpler because this is the simplest one I could think of off the bat. Something I hadn't noticed throughout the whole production of this is that little error there with the wall. But it does exist, and that should fix it. And if we press F5 now, keeping the frame rate really low just so we can see it, we see the whole thing go through. Another way to fix it would be to say when you multiply by total frames here, multiply by total frames minus 0.1 or something. But not only is that kind of messy, but it also, the more you manage that means technically the last frame gets shown for a short period of time as well, so we don't want that. So we still want to see that final frame for the same duration as all the others, and just make sure that that's the case. We see every frame for the right amount of time, it plays at an even speed, and doesn't mess up and shows that extra frame at the end there. Okay, so with that fix applied and our frame rate back to normal, we've successfully created a simple state machine that allows us to differentiate between running around like this and being in a specific state, doing a specific action like rolling. You know, so when we're rolling, just have to believe me, you can't change direction or anything like that because the code isn't there. The code is in a free state. Very, very useful. It allows us to create distinct blocks of code without worrying about all of the code that's in the other state, because we just completely ignore it when we are in a given state. So when we are in the free state, we ignore what's in the roll state, and when we're in the roll state, we ignore what's in the free state. Very, very useful. Alright, thanks for that, guys. Hope you enjoyed that. Hope you managed to make sense of it, and I'll catch you guys in the next one. Thank you very much for watching, part. Hello everybody, welcome to part 5. This week we're going to be creating a core game object, which we'll call OGame, that's going to manage the game, so to speak. It's not actually going to do a whole lot, it's going to mostly initialize things, so any like settings and things we need to change or run in code right at the very beginning of the game, any global variables we need to establish, that kind of thing, or handle anything meta, maybe in like debug commands and things like that, that we need to put into the game that don't really fit into other isolated or unique manager objects. Okay, that doesn't take a whole lot of time to set up, so we're also going to be doing a couple of other things. We're going to be bringing in our first tile set and sort of decorating our room so it doesn't just look like all these red squares anymore, and we're also going to be, what's the other thing again? Oh, that's right, we're going to be pausing the game as well. We're going to be showing you how to get pause system in. Nice to have that in early. I think I did it actually quite late in my pre-production stuff, but having that in early is nice to make sure it's enveloped everything consistently throughout the project. So first of all, I'm going to clean up this room and also create a few new rooms in our room structure. So I'm going to go to the call layer first of all, and just select the tile, get a nice big brush, and just right click, just erase everything. We're also going to delete the player for now from this room as well. And what I'm going to do is I'm going to rename this room our parent. Actually, I think I will have a player, so I'm probably always going to want an instance of the player in every room we make. So what this room is going to do is act as a parent room, if you will, for any rooms in our game. All that means is we're going to kind of use this room as a template for other rooms to copy from, mostly in terms of layer structure. Okay, so what this does is, if I have certain layers I know are going to be in every room, if I always have an instance layer, I always have this color layer of buildings, if I always have certain tile layers drawing tiles, I can just add them to the parent room and they'll be copied across into other rooms, alright? So I'm going to right click on parent and hit create child, and you'll see it like turns into a little tree form, and call this our village, the name of this room. It's going to be the room from the demo with the two little houses in. And you see it's just made, you see we're in our village now. It might look like we might actually move anywhere. It's the same as this. It's made a complete copy, basically, of the other room, even down to where the player is positioned and that. As I said, the main use of this for us is to create a layer structure that we can copy from room to room. So if in our village I just go into the call layer, you see that each one of these has become kind of highlighted, and that's showing that it's basically inheriting that layer perfectly from the... so I'm going to... probably always going to want an instance of the player in every room we make. So what this room is going to do is act as a parent room, if you will, for any rooms in our game. All that means is we're going to use this room as a template for other rooms to copy from, mostly in terms of layer structure. Okay, so what this does is, if I have certain layers I know are going to be in every room, if I always have an instance layer, I always have this color layer with buildings, if I always have certain tile layers drawing tiles, I can just add them to the parent room and they'll be copied across into other rooms, alright? So I'm going to right click on parent and hit create child, and we'll see it like. tree form and call this our village. The name of our first room. It's going to be the room from the demo with the two little houses there. And you can see it's just made, you see we're in our village now. It might look like we've not actually moved anywhere. It's the same as this. It's made a complete copy, basically, of the other room, even down to where the player is positioned in that. As I said, the main use for this for us is to create a layer structure that we can copy from the room. So if in our village I just go into the whole layer, you can see that each one of these has become kind of highlighted, and that's showing that it's basically inheriting that layer perfectly from the parent room. Whereas if I, and even if I draw here, like it's still inheriting because it's just inheriting all the properties of that layer from. Okay. Whereas if I made a new layer, you see it kind of breaks all of them because they would then all have different depths and so on, right? Anyway, let's just clear that up for a second. If I come back into our parent and I add another layer in here, just call this, put it under there, another tile layer, and just call it tiles main. It's just going to be one for drawing our main sort of artwork. And I come back to our village, you see our village has now got that layer as well. Also, you can see on the call layer, if I draw this here and I come back into our parent, that doesn't duplicate back in here because this is the child, and this is the parent, okay? That's not the only room I'm going to make. I'm actually going to duplicate our parent here as a room outside of this inheritance tree and just call it our init, short for initialization, and drag it right to the top so it's the first room we have a load when we run the. Okay. The parent, okay? That's not the only room I'm going to make. I'm actually going to might look like this room as a template. If I have certain layers I know, I can just add them to the parent room and they'll be copied across into other rooms, alright? So I'm going to right click on parent and hit create child, and you'll see it like kind of turns into a little tree form, and call this our village, the name of our first room. It's going to be the room from the demo with the two little houses there. And you can see it's just made, you see we're in our village now. It might look like we've not actually moved anywhere. It's the same as this. It's made a complete copy, basically, of the other room, even down to where the player is positioned in that. As I said, the main use for this for us is to create a layer structure that we can copy from room to room. So if in our village I just go into the whole layer, you can see that each one of these has become kind of highlighted, and that's showing that it's basically inheriting that layer perfectly from the parent room. Whereas if I, and even if I draw here, like it's still inheriting because it's just inheriting all the properties of that layer from. Okay. Whereas if I made a new layer, you can see it kind of breaks all of them because they would then all have different depths and so on, right? Anyway, let's just clear that up for a second. If I come back into our parent and I add another layer in here, just call this, put it under there, another tile layer, and just call it tiles main. It's just going to be one for drawing our main sort of artwork. And I come back to our village, you see our village has now got that layer as well. Also, you can see on the call layer, if I draw this here and I come back into our parent, that doesn't duplicate back in here because this is the child, and this is the parent, okay? That's not the only room I'm going to make. I'm actually going to duplicate our parent here as a room outside of this inheritance tree and just call it our init, short for initialization, and drag it right to the top so it's the first room we have a load when we run the game. And I'm going to delete OPlayer from this room so it is just this black rectangle, but still with our width, height, and viewport settings and stuff for game resolution. And I can go ahead and delete these tile layers because I don't need them in the initialization room. This is a room where we're going to put our game object, and then our game object is going to initialize some settings and bring us through to whatever room we want to actually start in, which would be our village room, right? So we never actually load the our parent room, it is just there as a template for other rooms. So we'll skip straight from our init to our village, and then from our village to whatever other levels are in our game. We never actually go to this room, it's just there as a template for our other levels. Do be careful if you're editing these rooms that you're editing the right ones. Obviously they all look very alike at the moment. You can always just check with that to make sure you're on the correct room.
So in case you do not know, the stock market is currently in a bull market, which started in October 2022.
Okay, so just back in the workspace, I'm going to right click the resources, create sprite. And we're going to bring in the tile set for decorating our village. So I'm going to click import. Levels are in our game. You never actually go to this room. It's just there as a template for our other levels. Do be careful if you're editing these rooms that you're editing the right ones. Obviously they all look very alike at the moment. You can always just check with that to make sure you're on the correct room. Okay, so just back in the workspace, I'm going to right-click over Resources, Create Sprite, and we're going to bring in the tile set for decorating our village. So I'm going to click Import. Again, this is back in our ARPG assets folder with all of our artwork. I'm going to find S tiles. For those of you making your own artwork, this is, I think, 16 by 16 tile set. As in each tile is 16 by 16. You can choose what size you want. It's just where all the artwork for the game is going. But if you're working with the same resolutions as me, then it's 16 by 16 tiles. Make sure the top left one is blank. I've not organized this very well. For some reason, the entire top row is blank. It's all just kind of a mess. But it doesn't really matter too much in terms of how I place this stuff. I've actually technically got a couple of like 16 tile like auto tiles up here, but I actually don't really like the way GameMaker's Remeditor works with 16 tile auto tiles. I find it quite limiting and hard to use. I mostly just place all my tiles manually, so I don't really bother setting that up. But yeah, that's the sprite. Don't need to do anything with the origin or collision mask, this just needs to be in. And I've got S tiles, this is more or less all of our tiles. Then you need tile sets. Create a tile set and call it T tiles, just the same really. Assign the sprite to be S tiles. Mine by default on 16 by 16, so just make sure that's correct. You see your top left isn't anything, and all the tiles fit neatly into those squares. Alright, with that tile layer set up, let's come back to our village. Make sure it's our village, as I say, they're all quite similar. We've got that tiles name. If you haven't made that layer already, make sure you go ahead and make it in the parent one, so it's inherited in the wheels. But in our village, select that layer, select the tiles set to be T tiles. And then if you go to the room editor tab over here, if you don't have that, for whatever reason, like you accidentally close it down, it'll be room tile editing tile selection window, and bring it back. If you accidentally close any of these windows, generally it'll be like another thing, depending on what editor you're in. This is a room editor, so there's a room one here, and you'll have all the different windows that should be up, so you can use them back that way. Okay, let's bring this up. My monitor is super zoomed out, so it's 16 by 16 tiles. I have to press control now, so we can kind of zoom in. And I'm just going to quickly, just by clicking and sort of, clicking and clicking to remove, I'm just going to draw in the village. think that'll do for now for the base tile layer. Just one thing I should probably explain that I'm also going to add with this. Obviously, sometimes you'll have tiles like I do here that you want to draw above other things, so don't be afraid to just add more tile layers. And like, this tile layer is never going to interact with anything game-wise. It doesn't really matter what it's called or how many of them you have. So I'm just going to go into parent, and I'm going to add just another one above here that's called just tiles upper, and I'm going to set it to be the exact same tile map back to our village, and we've got this one as well, and which just then lets us place some more tiles above the layer we currently have, and just pop some kind of flowers and stuff about the place. Yeah, just a handful of that, that was fine. Alright, so that's our village, now a bit easier to distinguish from our other rooms. I'm going to move the player first of all when I'm standing on this wall. I'm just going to change this to like 8 by 8 or something, just so I can move there just around the snap objects around a little bit easier. And then I'm going to come to the color layer and just paint in the collidable areas. Okay, well that's a good point actually. If I come to our parent and move this above the other things just so we can actually see it above our art tiles, okay, that's important. We can back it easy, that's inherent to find. It's important we actually be able to see it above the art, so we can see what we're doing. So I'm just going to paint in where I want to be collidable. So as we're working off here, we'll put an invisible wall there for now, we'll do something about that later, not sure what. And yeah, we'll also stop working off it just for now, because we'll make that an area transition eventually. that's fine for now. That's everywhere we complied with. And that would all work, other than the fact we can't actually get to this room, so we're stuck in our init at the moment. No way to actually get to this room, it would work. Obviously, as well, we're going to eventually put roofs on our buildings as well. They're not just going to look like these empty spaces. But we're going to save that for a future episode. I'm going to deal with, we'll put those on at the same time as I deal with making it so you can have rooms that you don't aren't necessarily room like this one will be a transition. We'll go from this to a separate room entirely where we have a shop. Whereas this one will just be one where we kind of make the roof transparent once you go in and you can kind of see what we're doing on the inside. So they're two different things. So we're going to leave them for later. For now, they can just kind of look like this, which I think is fine. Alright, so now it's about time to actually make that game object I was talking about, the main focus of this actual episode. So I'm going to right click on object, hit create object. Import O game. I'm going to mark it as persistent. That's very important. I'm just going to close the room editors that we've got. I'll just close that down. Yeah, so I'm going to mark it persistent because this object is going to hang around between rooms. Like you say, this is this object will persist between rooms. So we make it once in our init, and then it will always exist in every room as long as we never explicitly destroy it. So there's going to be a few events in this. First one's going to be the create event. Make the code nice and big. I won't necessarily maximize this because we're not going to be in this code window for very long. But later on, this will develop into a code window with quite a lot of things, and it'll be where we do all of our global variables and where we initialize a lot of different things. Not a whole lot to do right now that needs initializing. Just a handful of things really. We need to set a global for our game pause state. So we'll do that global.game pause equals false. And the only other real thing is to go to the next room. Go to the appropriate room. And type room underscore go to open bracket room underscore start in all caps, which is going to be a macro. I'm going to find the macros real quick. Add hash macro room underscore start space and then the name of whatever we want to be the initial room of the game. Since it doesn't matter anymore. It's at the top. We need to know which one we want to stick to. That's going to be our village. Alright, and then that allows us to easily change that if we ever want to start in a different room testing and so on. Okay, back to the workspace now, that'll go red. Those are the only two real things we need to create event. Now I'll put a description in here as well, just feels right. Access, initialize, and globals. That's the main thing we're going to do in here. While I'm here as well, I may as well also put randomize, open bracket, close bracket, semicolon. That's a function that will just change the random seed of the game. Okay, just to make sure, if you ever do anything in the game, and most games of any complexity usually have some element of RNG in somewhere or other, not all, but for that majority, you probably want to have this somewhere unless you're doing something specific, because otherwise every single time you run a game, the random results are always going to be the same. That guarantees, like if you make a game that generates 3 random numbers and just come into the screen and say they number 12, 32, 56, every single time you ran it, it would come with 12, 32, 56, every single time, unless you have this randomize function carry out just once at the start of your game, just to randomize the seed of RNG for that game. Alright, so that's the create event for now. As I said, there's not much going on in here, but as the project develops, a lot more stuff will be getting added to this, specifically a lot of global variables and things like that that we'll be declaring will go in here, and so on. Alright, next I'm going to add a couple more tiny events. First is going to be a key press letters R event, mostly for us rather than the players. We'll probably remove, if you want to ship this to players, it's good to remember to remove this before you actually do. Unless it's a small game you want R to be just a game restart button. We're literally just going to have this event restart the game. So game underscore restart, open bracket, close bracket, semicolon. Alright, that's just for us, just so that when we're running the game, we can quickly just press R to restart. Next one, we're going to add the room start event, which is somewhere the other room start. So this event will get carried out every single time a room is started. Generally a helpful event in a persistent object, so that when you go from room to room, this is going to happen every time we do like we do in here, we go to another room, and that room is initialized in the game. These things will happen, okay? Including when we go to, like if we go from that room back to our init for some reason, or to another level, and then we come back to our village, it'll happen again. So every single time a room is started, alright? So on room start, what we want to do is, I'm going to set the description of this to be layer management. And the only function I'm going to carry out in here now is layer underscore set underscore visible, open bracket, call, quotation marks, comma, false, close bracket, and so on. Alright, that is going to take that collision layer and set it to be invisible. Obviously, if we have it invisible already, that's fine. It goes from invisible to invisible. But if it's visible, it goes from visible to invisible. That just lets us keep this on while we're editing and drawing like our collision files around, and we're toggling it on and off. We don't have to worry about going through every single loop, turning this off every time we want to run the game and see what it looks like. We can just leave it on while we're editing. Very useful.
I've discovered a business model that allows people to make earnings like these. And most people don't know this. But this
So as you can see, just sometimes a lot of code you add is not necessarily about like the end result of the game, end result of the game that the player is going to see. But sometimes you're adding code that's essentially just like a framework for you, right? Like the scaffolding around your game, if you will, that allows you to build on it easier. All right, and the last event we want to add in here for now is the end step event. So step, end step. Again, I can't remember why I used the end step specifically for this one, but there will be a good reason in terms of the ordering and stuff like that with other objects and things later on. But the important thing is just like a normal step event, just carried out every step, just carried out after all the other step events of other objects in a particular step. Alright, so the description for this one is pause the game. Alright, this is just going to be about us pressing like the escape key to pause the game. In fact, before I actually do anything more in the last one, let's just show you now. If I press F5, oh wait, nothing happens because we don't have OGame in game. So go to RNet, go to resources, on the instances layer. Again, make sure it's RNet and not R parent, and just stick a copy of that object in. You see the question mark, it's got a sprite sign. We won't actually draw that, we're drawing this frame anyway. It's just going to be an invisible object, and that'll just. So the first thing it does when you're in the game is it loads RNet. Loads this object, and then an object known as create event sets this work. Variables and set it RNet system. So everything. So that's the create event for now. As I said, there's not a random element in other games. It doesn't matter anymore. We easily change that if we ever want to start on a different from testing. and so on. Okay, back to workspace now, that'll go red. Those are the only two real things you need to create a event. Now I'll put a description in here as well, just feels right at best. Initialize and globals. That's the main thing we're going to do here. While I'm here as well, I may as well also put randomize, open bracket, close bracket, semicolon. That's a function that will just change the random seed of the game. Okay, just to make sure, if you ever do anything in your game, and most games of any complexity usually have some element of RNG in them somewhere or other, not all, but the vast majority, you probably want to have this somewhere unless you're doing something specific, because otherwise every single time you run a game, the random results are always going to be the same. That guarantees, like if you made a game that generated 3 random numbers and just printed them to the screen and say it came up with 12, 32, to 56. Every single time you ran it, it would come up with 12, 13, and 56. Every single time, unless you have this randomize function carried out just once at the start of your game, just to randomize the seed of RNG for that game. Alright, so that's the create event for now. As I said, there's not much going on in here, but as the project develops, a lot more stuff will be getting added to this, specifically a lot of global variables and things like that that we'll be declaring will go in here, and so on. Alright, next I'm going to add a couple more tiny events. First is going to be a key press letters R event, mostly for us rather than the players. We'll probably remove, if you want to ship this to players, it's giving them to remove this before you actually do. Unless it's a small game, you want R to be just a game restart button. We're literally just going to have this event restart the game. So game underscore restart, open bracket, close bracket, semicolon. Alright, that's just for us, just so that when we're running the game, we can quickly just press R and start. Next one, we're going to add the room start event, which is somewhere or other room start. So this event will get carried out every single time a room is started. Generally a helpful event in a persistent object, so that when we go from room to room, this is going to happen every. So every time we do like we do near room go to another room, that room is initialized in the game. These things will happen, okay? Including when we go to, like if we go from that room back to R for some reason, or to another level, and then we come back to our village, it'll happen again. Every single time a room is started. Alright. So on room start, what we want to do is I'm going to set the description of this to be layer management. The only function I'm going to carry out here now is layer underscore set underscore visible, open bracket, call, in quotation marks, comma, false, close bracket, and go on. Alright, that is going to take that collision layer and set it to be invisible. Obviously, if we have it invisible already, that's fine, it goes from invisible to invisible, but if it's visible, it goes from visible to invisible. That just lets us keep, essentially just like, be showing it, yeah? The reason that object then is it, this is going to be an invisible object, and that'll just, so the first thing it does when you run the game is it loads RNet, loads this object, and then that object can then create event, sets the variables, and then the room go to and sends us to our village. Here we are, you see our collision or collision time, you can see our collision layer is invisible, even though in here it's fully visible, just so you can see everything we're doing so far is working. Always nice to check that. Alright, so back in this end step event, I will go ahead and maximize this now. We'll close down those rooms, I don't think we need to do anything more on them. And I think this is the last thing we're going to be doing this episode. So, pausing the game. We first of all just want to check if we're pressing the escape key. Simple enough. If, open bracket keyboard, store check, store press, VK escape. Open the braces. Really quick, easy way here to toggle a variable. So we've got global game pause, which is currently false. If I type global game pause and set it to equal not global.
1、3、あ、そう。
Alright, so back in this end step event, I will go ahead and maximize this now. We'll close down this room, don't think we're going to do anything more on that. And I think this is the last thing we're going to be doing this episode. So, pausing the game. We first of all just want to check if we're pressing the escape key. Simple enough. If, open bracket, keyboard, score check, or press, VK, escape. Open the braces. Really quick, easy way here to toggle a variable. So you know we've got global game pause, which is currently false. If I type global.game pause and set it to equal not global.game pause, that will just convert this boolean. Okay, so rather than being like, oh, if it's false, set it to true, if it's true, set it to false, doing this accomplishes the exact same thing. Because obviously, if game pause is true, then notting it is going to return false, and if it's false, then notting it is going to return true. Okay, so it just inverts it. Very useful. So we know we toggled it, so we know if we were paused, we're not anymore, and if we know, and we know if we were not paused, we are now. So if global.game pause. What we're going to do, what that means is we've only just paused. We just paused it because we know we've just done this, so we know this is the moment we either become paused or become unpaused. So if we just become paused, we're going to do with or, a rare usage. That all is a keyword, and it'll just select every single instance. Okay, every single instance, every object type that's currently active in the game. Alright, so with everything, game pause image speed equals image speed. So we're going to take the image speed of every single instance in the game, and we're going to store it in a variable within that instance. So every instance is going to save its current image speed, its current animation speed, right? And then we're just going to set that image speed to equal 0, which is going to stop them animating entirely. And I know some of you are thinking, well, hang on a second, that's not quite how a player works, but we'll come back to that, don't worry about that. This is more about like every other object in the game that will be using image speed, which is currently nothing. Our player is the only object, but later on there'll be plenty of things to animate, and so we will probably just use image speed to animate some of the simple ones, so it's still relevant, alright? Else, so if the game has just become unpaused, then what we can do is with or essentially the opposite. Image speed equals game pause image speed, and we will know that exists because the game is starting off pause. So we'll become paused first when we first press escape, set that variable and everything, and then when next press it and we unpause it, it'll set the image speed back to the existing. As I say, we're not actually going to see the result of this right away. We'll see it in a later episode when we have things to animate with image speed, but it's nice to have that. It's set up and ready now. In terms of pausing the player, because obviously they've got logic and stuff to carry out, and as I say, their animation doesn't actually use image speed. Okay, it gets the speed of the sprite, but it just adds that political frame. So what we want to do instead is in OPlayer, in the step event, we still want to get players' inputs, because when we pause, we'll probably have like a pause menu or something like that, I don't know, or we still want to be able to gather inputs from the player for any number of different reasons. So we'll allow all that to keep running, but here when we execute the state machine, I'm just going to wrap this in a if global.game pause. You can either do equals false, like that, or you can just put the not symbol at the start, okay, which is the same thing. Check what that is. False. So assuming the game is not paused, run the state machine, and in the state machine, in the state frame zone, that's where the animate sprite, so we know that will pause as mid-frame, okay? That's everything. So if I run the game now, pressing F5, moving around in here, I press escape, you can see it pauses mid-frame. More obvious if I do any roll, like that. It's not just totally paused. We're still running this code of the, where is it? There's the player. Yeah, we're still running this code every single frame at the moment. The game is still running. The game's not totally slept or whatever. So we run this, but every time we come to this, that's true, so we don't execute the state machine, and that carries out all the logic of the frame. So we're just going to stay in the exact same place because we're not going to move anywhere. Values aren't going to get updated in any way, and we're not going to animate in any way, so we're not going to frame on. So we're effectively totally paused. Alright? And then that's more or less the same way we can pause other things throughout the game. Okay, we're just going to keep wrapping stuff in this. That's why I like to set this up early, because if I want to do game pause in this way, and it's a simple, nice, effective way to do it, honestly. It can feel a bit like a janky thing to put into 2, I think it's already quite far developed to be like, oh, do I just wrap everything and every object, and like if the game policy is true, then don't do anything. But I think it's fine. I think it's easy to do if you get it in nice and early as well, so you don't have to be running around making sure you're chasing after every object and discovering when you're testing the game you missed an object or something like that. So of course, it's easier if you get it in early and you just remember to put it in as you make each new object. Alright, so that's pausing the game. That's initializing the game. I realize I haven't added that much exciting stuff to the game itself, but hey, we've got the tile set in now as well, so that's nice too. Thanks for sticking with this. That's episode 5. I'll see you guys on episode 6. And that was episode 5, episode 6.
Want to use AI to capture more high quality leads? This ad is made entirely out of AI. Even my
Hello everybody and welcome to episode 6. This week we're going to be making the camera for the game and also adding screen shake. Whenever you're rolling a wall, so screen shake. So I'm going to go ahead and make the camera object, right click on object here, create object. Camera. So I'm going to name it, I'm going to mark it assistant. No sprite or anything like that against another invisible manager object. Let's just close these rooms now, get out of the way. Now we've got a couple of manager objects here. I'm going to right click in object and hit add group, just to create a folder for us to manage these things and call it managers and stick them. Yeah, that's just so we can organize those into one place. As GameMaker develops over time, it's possible. The way the resource tree looks to you now in whatever the latest version of GameMaker is a bit different from how it looks to me, and so when I right click and hit add group, it might function a little bit differently. Don't worry if you struggle with some step-by-step elements of this tutorial when it comes to the UI. You might just have to fiddle around to find the alternative thing, but my point is it's fairly new software, okay? We're in version 3.2 and it's rapidly changing, and I'm aware of major changes that may or may not be coming to UI and stuff at the time. So if those things change, just don't panic too much, alright? Because there will still be a way of organizing things. The point here is just to make sure that we're organizing our objects in some way or another, okay? Just so it doesn't become one giant list of randomly named, randomly arranged objects that become very hard to search, okay? So as I said, when we're making a manager object, we want it to be created and looked after by our OGame object. So I'm going to come into OGame, and in its create event here, underneath our global variable section, we're going to have a section for creating manager object. And I'm going to assign them to global variables so that we can access them from any other object or any instance again. So I'm going to type global.iCamera, I standing for instance, so the instance of our camera, which will be the only one. Instance, install create, install layer. Open bracket, and these three things are kind of irrelevant. We have to put in the X, Y, the layer ID, but it doesn't matter, it just needs to exist. It doesn't really matter where it exists. Well, it actually doesn't matter where the camera exists, but the camera will control its own position, so we don't need to worry about that in terms of when we create it. So we can put it anywhere. I'm just going to put it 0, 0, top left of the room, technically, I guess. And the layer ID is just the right layer, so whatever layer it is. OGame is on, we're just going to put it on the same place. And the object is, of course, camera. Close that here, semicolon. So that made that now. My normally was making the object that we're working on until the very end, and then I want to forget to do it. So this time we're doing it right at the start of the episode. From this point onwards, if you have seen my camera video before, my screen shake stuff before, this is going to be mostly covering old ground, so I apologize for that. But I think it is always good to have kind of a refresher on how basic concepts work sometimes. Okay? Alright, so before we get started on camera itself, I'm going to come into our village and just make the room a bit bigger. I'm going to change it to 640 by just something I can remember, 360, because it's exactly double. Temporarily, just to give us some space to explore. So the camera is just beside the room. I suppose it's a little bigger, I don't know. There's lettering something going there, right? Just so we can demonstrate the camera is working without actually having to make a full blown room in this episode, okay? Also going to change the collision map. We'll just remove this wall here so we can walk out into the void just to see the camera working a little bit later on. Alright, so now let's pop into OCamera and the create event. We'll close the room editor and yeah, we'll go ahead and maximize this and also just make the code window nice and big. And so we're coming to a set of camera. Alright, so the first thing we're going to do is get the ID of the current camera. Okay, when I say the current camera, the camera is just beside the room. I suppose it is a little bigger, I don't know. There's lettering something going there, right? Just so we can demonstrate the camera is working without actually having to make a full blown room in this episode, okay? Also going to change the collision map. We'll just remove this wall here so we can walk out into the void just to see the camera working a little bit later on. Alright, now let's pop into OCamera and the create event. We'll close the room editor and yeah, we'll go ahead and maximize this and also just make the code go nice and big. And so we're coming to a set of camera. Alright, so the first thing I'm going to do is get the ID of the current camera. Okay, when I say the current camera, I mean the camera associated with viewport 0 in here, where we've got viewport and cameras with enabled viewport 0. Getting the ID of the camera associated with that view. We do that by typing, first of all, in the variable cam, the camera, equals view, underscore camera, full screen, focus square bracket 0, close square bracket 0. Simple as that, gets that camera's ID. We're also going to have a variable called follow, which is going to be the ID of whatever instance our camera is following, so the whatever instance we want to center the camera on. In this case, it's going to be a player by default. We could change that later. The next thing I want is I want to get the value of half of the view width and half of the view height. That's going to allow us to center our camera on wherever we're following, rather than positioning our camera like positioning the top left of the camera from that instance, alright? So I'm going to get that with view, w with half equals, let's put view with half equals camera underscore get underscore view underscore width, over bracket cam, close bracket, times 1.5. So we already divide by 2, but typically if I know how to multiply by something instead of divide it, I always multiply. So multiply by half. Do height half. But the reason I do that, I don't know if it's really a thing game or what. I heard somewhere that it's good programming practice to do that because typically a division takes longer. It's harder to do by a CPU. It's harder to compute a division than it is to compute a multiplication. I don't know how well that holds up when you think about it. Now we'll translate it down. I don't know. It could be more. But it's a habit I have, and it's something I do. It's technically best practice. So do it. It's really make a difference. But it doesn't make it worth it why I do it. All right. Half is obviously just in the camera. So again, do height can multiply by 0.5. The next couple of variables I want is x2 and y2. These are going to be the x and y coordinate that our camera is going to be heading towards. Right? Not where we're at, that's x and y, but where we are heading towards. Our x2 can start off as x start, which is good.
Oh shit. I just realized those comments. And I haven't been reading. Oops. Hello.
Just wherever the camera happens to be when it is first placed or created, and y2 will be y starts. And the last three variables we have to do space are all to do with our screen shape. We're going to have shape length equals 0, shape magnitude equals 0, shape remain equals 0. Alright, you might remember these from screen shape videos and so on. That's just going to be how long our screen shape will last, how strong the screen shape is, and how much of the particular screen shape is left to get. Alright, so with all those added and all those little yellow triangles warning us we haven't used those variables yet. I'm going to add the step event from the right in here, add such an event, step and step. Alright, so we've got purpose of tabs there. That's good.
Shape magnitude, shape length, shape remains. Okay.
I'm going to add the step event from the right in here, add such an event, step and step. Alright, so we've got purpose of tabs here. The title of the step event, update camera. That's all we're going to do. Okay, with all those added and all those little yellow triangles warning us we haven't used those variables yet. Of course we haven't, just really. I'm going to add the step event from the right in here, add such an event, step and step. Alright, so we've got photos of tabs here. The title of the step event, update camera. That's what we're going to do. Alright, so the first thing to do is just update position of the camera, and we're just going to have it every frame update its x2 and y2, being its goals, its x coordinate goal, its y coordinate goal, to be wherever our follow instance is. So if instance underscore exists, open bracket follow, just to make sure that there is an instance move forward, we'll do it. X2 equals follow dot x, get the x coordinate from that instance, and y2 equals follow dot y. Then we're going to smoothly move our x and y coordinates towards this position. Alright, so update object position. In fact, we should comment this bit as well. Update destination. That's where we're going, and this is how far along we currently are. So we're going to take our x plus equal, open bracket x2 minus x, so that's the difference between where we're going and where we currently are, divided by 15. So we're always going to move towards our destination by 15%, essentially every step. And do the same thing for your y coordinate, so y plus equals y2 minus y divided by 15 times 50. Feel free to play with those numbers just to get something that feels like you. I'm by 15, I think feels nice and smooth. You'll see the results. We don't want the camera to stretch beyond our room bounds, otherwise we'll just show black at the edges. We don't have any control of that. So we want to keep camera center inside room. It's a little tricky, we can't calculate why we'll do the camera in the room bound, because we have to account for the fact that the camera is not content space, it's a whole rectangle of space, right? That rectangle inside the larger rectangle that is our room. So essentially, we know all of the values that can help us do that by taking advantage of half of our camera width and half of camera height. Okay, so x is going to equal clamp. The function less is putting the value and minimum and maximum, just keep that value between those two numbers, very, very useful. The value that we're going to give it is our x. The minimum that we're going to give it is view width half. So the minimum is number 0 to the far left of our room, so view width half is closest we can get our rectangle to the very left before we go outside the room. And maximum will be room underscore width, so full width of the room, minus view width half, close brackets, and so on, right? And the exact same thing for y. So y equals clamp, y view height half, room height minus view height half, close brackets, and so on. Alright, next we're going to just add in the code to apply our screen shape. Since we've done all kinds of where we're moving it from the camera, we can kind of add a bit of screen shape on top of those x and y's just to wobble our camera around whenever we want to. So I'll comment screen shape, screen shape, there we go. X plus equal random underscore range, takes two values and gives you a random number between them. Negative shake remain, positive shake remain. So if shake remain was like 10, we would obviously have the combination 9, 10, and 10. Alright, and the same for y. So y plus equal random underscore range, minus shake remain, shake remain. Alright, then we want to reduce shake shape remain towards 0. Alright, so shape remain is going to equal max, whichever is the biggest out of these values, 0 for itself minus some value. Right? Shape remain minus open bracket 1 divided by shape blank, close bracket, multiplied by shape magnitude, close bracket, same one. So I guess it seems weird. Shape remain will initially be set to whatever shape magnitude is, right? And we're going to remove a fraction of shape magnitude from shape remain every single frame. So if our shape magnitude is like 100 or whatever, right? Shape remain got set to 100 and it'll be really big, really wide screen shape, so it'll probably look terrible. Say it was 100. Whatever is in shape length is however many frames we want the shape to last. So say that that's 10, right? 1 over 10 is, a tenth. Okay, so 0.1, so 0.1 times shape magnitude, meaning we remove 1/10 of our shape magnitude from shape remain. So 10 frames later, we will remove all shape magnitude from shape remain, and we'll have shape length. And that's why shape length is then how long the shape is in terms of number of frames. Magnitude is how big the screen shape starts. This is so that like, we don't shape, like, say in that case we have 100, and we're shape 100, we're shape 100 for all of it. It starts off big and then just linearly sort of dissolves into like big shape all the way down to really small shape by the end of it, alright? Then finally in the camera, all we go do is actually position our camera, our actual camera, wherever this instance happens to be. Okay, so camera, underscore set, underscore view, underscore pulse, for position, open bracket, cam is in the camera. The x position is x minus view with half, because remember, the position of this instance is the center of wherever we want our camera to be, right? When we're setting view pulse, we're actually setting the top left of the rectangle. So in order to make that match up with wherever the center point happens to be, we need to subtract half view width and half view height from those coordinates. So the x is x minus view with half, and the y is y minus view height half. Close brackets and go on. Do that to do some sort of count of how many times I say close brackets semicolon. Yes. Quite a lot, every line. Alright, so that's the whole camera. I know we haven't written anything to actually fly the screen shape, but we can go ahead and try that now since we know games creating camera. If I press F5, we come to a village, we've got camera, and we see it's already summed down a bit here, and we see blackness, and we see camera follows. I'll go around even to one round F5, we come to a bit. Give you some sort of count of how many times it remove this wall from. In this case, it's going to equal 0. That's okay. Alright, so before we get started on camera itself, I'm going to come into our village and just make the room a bit bigger. I'm going to change it to 640. By, just so you can remember, 360 is exactly double. Temporarily, just to give us some space to explore. So the camera is just the size of the room. I suppose it is a little bigger, I don't know. There's slightly something going on, right? Just so we can demonstrate that the camera is working without actually having to make a full room. That's okay. Also going to change this wall here so we can walk out into the void just to see the camera working a little bit. Alright, now let's pop into camera and have the create event. We'll close the ring editor and yeah, we'll go ahead and maximize this. And also just make the code window nice and big. And so the command to set of camera. Alright, so the first thing I'm going to do is get the ID of the current camera. And when I say the current camera, I mean the camera associated with viewport 0 in here. There we go. Viewports and cameras enable viewport 0. Getting the ID of the camera associated with that view. We do that by typing first of all name of the variable camera equals view underscore camera, there's me, open square bracket 0, close square bracket equal. Simple as that, gets that camera's ID. We're also going to have a variable called follow, which is going to be the ID of whatever instance our camera is following. So the whatever instance we want to center the camera on. In this case, it's going to be a player by default. We can change that later. The next thing I want is I want to get the value of half of the view width and half of the view height. That's going to allow us to center our camera on whatever we're following, rather than positioning our camera like positioning the top left of the camera on that instance. Alright, so I'm going to get that with view w half equals, in fact, let's put view width half equals camera underscore get underscore view underscore width open bracket cam close bracket times 1.5. Or you can divide by 2, but typically if I know how to multiply something, then divide it, I always use it. So multiply by half. View height half. Well, the reason I do that, I don't know if it's really a thing game or what. I heard somewhere that it's good programming practice to do that because typically a division takes longer. It's harder to do by a CPU. It's harder to compute a division than it is to compute multiplication. I don't know how well that holds up when it comes to running GML. Maybe it'll get translated down and multiplied. I don't know. It's really but it's a habit I have, and it's something I believe is technically best practice. So do it. It's really different, but just in case you wonder, I do that. Alright, half is obviously just camera, so we'll get view height and multiply by 0.5. The next couple of variables I want is x2 and y2. These are going to be the x and y coordinate that our camera is currently heading towards. Right? Not where we're at, that's x and y, but where we are heading towards. Our x2 can start off as x start, which is just wherever the camera happens to be when it is the first place it'll create, and y2 will be y starts. And the last three variables in absolute space are all to do with our screen shape. We're going to have shape length equals 0, shape magnitude equals 0, shape remain equals 0. Alright, you might remember these from screen shape videos and so on. That's just going to be how long our screen shake is going to last, how strong the screen shake is, and how much of this particular screen shake is left to go. Alright? Okay, with all those added and all those little yellow triangles, we haven't used those variables yet. Of course, we haven't. I'm going to add the step event from the right click in here, which adds action event, step, and step. Alright, so we've got both those different add and we'll title the step event update camera. That's what we're going to do. Okay, with all those added and all those little yellow triangles warning us we haven't used those variables yet. Of course, we haven't. I'm going to add the step event from the right click in here, which adds action event, step, and step. Alright, so we've got both those different add and we'll title the step event update camera. That's what we're going to do. Alright, so the first thing to do is just update the position of the camera, and we're just going to have it every frame updated x2 and y2 being its goals, its x coordinate goal, its y coordinate goal, to be wherever our follow instance is. So if instance underscore exists, open bracket follow, just to make sure that there is an instance to move towards, so we'll do it. X2 equals follow dot x to get the x coordinate from that instance, and y2 equals follow dot y. Then we're going to smoothly move our x and y coordinates towards this position. Alright, so update object position. In fact, we should comment this bit as well. Update destination. Alright, that's where we're going, and this is how far we currently are. We don't want the camera to stretch to the center of the camera. So numbers half, we go outside the room. And the maximum would be room underscore width, the full width of the room, minus view width half, close bracket, and go off, right? And then the exact same thing for y. So y equals plan, y view height half, room height minus view height half, close bracket, and go on. Screen shake is random, just range, you make power, what? See, y is screen shake, so, blue, left, those coordinates. So the x is x minus view width half, the y is y minus view height half. Close brackets and go on. We'll have to do some sort of counter how many times I say close brackets semicolon. Quite a lot every line. Alright, so that's the whole camera. I know we haven't written anything to actually apply the screen shape, but we can go ahead and try that now since we know the game is creating the camera. If I press F5, we come to a village, we've got the camera, and you can see it's already some down a bit here, and you see the blackness, and you see camera follows, up there around, even if we wander around to avoid the space itself. Alright, all works quite nice and smooth. Let's go. Alright, let's very quickly. To manage these things in court.
It works. It works. It fucking works. Yeah, I like how the camera like slowly follows. So smooth.
Base itself. Alright, all works quite nice and smooth. Let's go. Alright, let's very quickly add the script for applying the screen shake at the end of this. So in the script, I'm going to create a script called screen shake. And save some time, I'm going to copy and paste in just from my notes the description of the topic here. So at desk, the name of the function and what goes into it, and names the arguments. This basically makes it so even if I write it in here, recursively open bracket, you can see a bottom comes up, magnitude, frame. I don't know, based on some changes that Yo Games announced coming to GML, they're changing how scripts work in the future, possibly by the time you're watching this video, who knows. And they are going to make it so that each script as a file, so it's in the screenshake.gml, can contain multiple functions, right? Don't really use scripts as functions, right? We make a script and then call that script as a function. They're going to make it so that scripts can contain multiples of these. You can define like several functions within one script, and then you can call them from your objects or wherever else you want to, right? So it's possible that this whole setup here where you write this might change. It's possible that these scripts become a thing whereby it's anything you want. I'm actually in here and I'm writing like function, screen, shake, and then like this, and then defining the scripts that way. You should know that when that happens, all this stuff in the tutorial will also work, right? You just might want to structure it a little bit differently and so on. I don't know when those changes are coming, frustratingly, so I can't base this whole story series around that. I'm not going to go back and remake it all when those changes come out. But I just want you to be aware in case the stuff I'm doing in the scripts now will start to get script heavy stuff, in case it changes and looks drastically different from the version you're currently using in the future. Just know that it's not a problem, alright? And hopefully how I've explained it, how it's going to work in the future, how I think it's going to work in the future is correct, and you can then just follow along and adjust for that slight change, alright? Alright, anyway, so this screen shake script, what's going to go in here? Let's delete that one, so just random. Yeah, so in the screen shake script, we're going to basically just assign those three variables that we made in the camera object. So I'm going to do with, open bracket, global.i camera, this is handy now. You see, you remember I was talking about before when since we do know that there is something like in the download camera, we can write something like OCamera. To get the idea of it, but it is nice and good practice if you do have the specific instance ID that you're looking for to just reference that instead. To save GameMaker having to go through like finding the list of instances of OCamera and translating that. Basically, it would save GameMaker a job of writing OCamera into the ID of one of the instances of OCamera in the room by just getting the very specific instance ID that we know exists. Okay, and we know that exists because we created it in OGame at the very start of the game. So with global .onCamera open braces, if argument 0, that might change as well. Coming to GML in the future, you might be able to enable, be forced to name all arguments of scripts. So be on the lookout for that. If argument 0, right now argument 0 doesn't work in the newer future version of GameMaker, you may want to look in the manual to find out how it is these things that name arguments and do that and give it a name. It might be as simple as what I've done here with magnitude or whatever the stuff here. Maybe I'll be able to write like magnitude. I don't know. In the current version of GameMaker, in 3.2.5, 2.2.5, it's you're going to want to write argument 0. Yeah, I mean we could always write something like var magnitude equal argument 0 and then write magnitude in there. But even that would change because if argument 0 stops being a thing and so on. I don't know how it would work, but I know that change will come at some point in the future. Alright, so if argument 0 greater than shake remain. Okay, braces. So we don't want to apply a new screen shake if the screen shake we're going to add via the magnitude is smaller than the screen shake we already have in effect. Alright, there's no point, right? We're not gonna, because we just end up taking a big screen shake and reducing it to a smaller screen shake then, alright? Like overwriting to a different one. So we're going to assume we're just going to take whatever the biggest screen shake is and give that precedence. So assuming this is the biggest screen shake that we want to apply. Shake magnitude, magnitude equals argument 0. Shake remain also equals argument, really there equals shake magnitude, which of course is argument 0, and shake length equals argument 1. Alright, and that's all scripts, so we can call it now wherever we want and set our screen shake appropriately. So if I go into the PlayStation roll script, you remember we actually found out when or if there was a collision. That's quite cool. At the moment it doesn't do anything for our roll. I'm going to make it so it ends the roll state and also causes a screen shake. Okay, we're going to do more than that. So we're building on roll really obviously. Because we can also add the bounce effect, kind of like in Zelda when you roll into a tree and you bounce off it. But for now we're just going to stop. So I'm going to type if install collider state equal player state 3, exactly the same as this if statement, but we don't want to. And on the input, we also want to write screen shake, open bracket, 2x for magnitude range. Magnitude can be 8, and frames can be 30. I can't remember those numbers I used in the original demo, but we'll find out if it looks okay. So now from that, press F5, run this, and it's run around if I roll. Well, that's pretty big screen shake, probably bigger than 1. Looks a little weird at the moment because we're not bouncing off the wall. But it's still kind of getting most of the effect that we're actually kind of shaking. We can change that magnitude down for give it kind of subtler screen shake, the same amount of time. So it's a smaller screen shake, but what feels like longer. Alright, and that's that. Thanks for watching, guys. Hope you enjoyed this one. I'll catch you all on episode 7. I think it's episode 6, so I'll catch you guys on the next episode. Alright, thanks, guys. See you then. Patreon, yeah, you all know the deal here. These are the people who made this video happen. They're all awesome. Extra special events in no extra special order. Two phones, Daily Raid, Bounce for a Dog, the TT, Habit Pants, Dapper on the Go, Dark Rider 0318, Do What Beauty.
Magnitude 4, 60 frames, 30 frames per second, 60 means 2 more seconds.
Hello everyone and welcome to episode 7. In the previous part we've been doing a lot of framework and setting up for the action RPG. In this part, because there's a few different directions we could go, we could keep building on the framework or do something a little more interesting, I decided to give my Patreon supporters a vote on what topic we should look at next. And by far, in the end, the winner was dialogue, so looking at how to create the dialogue and branching dialogue that we saw in the demo. Now, it's a tricky subject and it's going to take more than one episode to cover, all the little sort of intricacies in that. So in this first part, what we're going to do is just looking at setting up the text object that will render the text to the screen. We'll draw the text box to animate appearing and be able to draw a message letter by letter. So I'm going to start by adding the macros and globals that we're going to need along the way. So I'm going to open the macro script. And I'm going to add 2 new macros that are going to be useful not just for this episode, but for a lot of things around the game. The first one is going to be resolution underscore W. We know by now the resolution of our game, we decided on it very early on, is 320 by 180. So the width, resolution underscore width is going to be 320. And as you may guess, we're going to have a macro for height as well, so resolution underscore H 180. So then, any point in time we do go insane and we decide we want to change the resolution of the game, we can pop over here to replace these figures rather than having to replace them all the way throughout the game, because there's going to be plenty of times where we want to draw something relative to the screen or find a position relative to the screen where no one of these numbers. Is going to be very, very useful for us. Next up, we're going to close that and we're going to open OGame and come to the creator where we've got our couple of globals set up in here, and we're going to slot one more in between these two. And I've got where just a variable, so we'll be at the top. I'm going to create a global called text speed and set it to 0.75. Fine. In case you didn't know, in a lot of programming languages actually, you can write a decimal number, like this is 0.75, you don't have to include the 0, because 0 is implied. If you don't put it down, you can put 0.75, just a quick way of writing it if you're just dealing with a number between 0 and 1. That's the only global we're going to need for this particular tutorial, so I'm going to go ahead and close OGame now. And then I'm going to have a script that I'm actually going to import from the already completed project, and I'll explain why in a second. So this script I've got here is called 9 slice box stretch. This might be familiar to some of you if you've watched my tutorial video on creating 9 slice boxes. I think the tutorial is called UI boxes / windows or something like that. If you want a really in-depth explanation of this script, you can go watch that video. I'll put all those cards in and I'll put it in the description as well. But like that video's over 30-minute tutorial, so I wasn't going to go over all of this in this one particular video. In short, what it does though is you can see it takes a bunch of arguments in whenever we call the script for the coordinates of a box. And using those coordinates, it takes an image that you provide it and chops it up into 9 pieces. So the 4 corners, the middle, and 4 edges that will.
Hey, you know what? I'm just gonna stop here and take a break.
Make a black box, stretches out where it is in the middle to cover the box, draws the 4 corners, and also draws the edges stretched out to fit the box as well. So you can draw a box of any size using a single stripe to determine what it looks like. Speaking of that single stripe, we need to bring that in, so I'm going to create a new stripe, hit import, and I believe, yeah, S text box. S text box PG underscore script 4 is the one from mine. for those of you making your own, not using analysis, this is what it's like. We've got 4 different types of imaging here, 4 different types of text box we might use throughout the game. Okay, this one here is for like our save slots on the menu stars. We've got like selected and unselected, and these 2 are just 2 different types of dialogue boxes. One's like for signposts, and this one's for like dialogue and like messages from NPCs and stuff like that. So you can see if I edit it, and if I just bring up a grid, it's always hard to see on when you split this to, I think it's 8 by 8. Kind of hard to see on my the resolution recording this, I'm not sure what I'm going to do, but basically I'll just draw in real quickly in the controls here. But we've got like this kind of grid. Okay, so I'm picking 4 corner pieces, 4 edge pieces, and middle piece, and we designed this where these like stretch outwards. It has to be quite simple to work with this particular script. If you go watch the other video, I do show how to make a script that uses a lot more panning ones as well. But basically these edges here do have to basically be the same pixels all the way down. So like you basically design like this row, and that's about it, because that gets stretched to the full size of the box. Okay, and in the middle you can't really have anything but a solid color, because it just takes the top left pixel and just stretches it up with the dialog box. The corners you can do pretty much whatever you want with, because we just draw those as they are, so those can be a bit more fancy detail if you want to be. Okay, and we also need to name this sprite for us, so I'm going to call it S text box BG with that capitalization. Origin can say in the top left, and that's what you do with that. One other thing to remark about this script, I believe I mentioned this last episode, but just a reminder for anyone that might be using a future version of GameMaker, because we've all seen some of the changes that have been announced by the games. Likely to come into like version 2.3 or whatever, right? Maybe 2.4, I don't know. But whenever it comes, there will probably be changes to the way scripts work. It's possible, even very likely, that arguments will no longer be a thing in the same way, and you have to sort of name them specifically to a function, and also the scripts will contain functions rather than being functions in their own right, okay? So you might have to end up doing something like function 9 sliced box stretched. Open code brace, close code brace, like something like that, right? Around order. Trying things.
Using a laptop PC, I'm using a PC. Not a very strong one. And my computer is hanging. Oh, Ryzen 5900X. along with I think it's RTX 3080. Well, I forget where I can see my graphic cards, but yeah, I think it's RTX 3080. Well, it's decent enough to run GameMaker Studios.
To future-proof my videos.
Okay, so apparently I need to type out this whole chunk. That's long. Nice box stretch. 1, 2, 3, 4. And that's low. Given 0 size. X1 size. Plus size. W minus size times 2 H minus What's that? Increment index 0 size 1x
goes against all of the crazy and the very, very cool changes that we're going to get in the future. Anyway, yeah, I'll make this as big as I can fit on the screen. Something like that. Pause the video now, get all this copied down, or you can go and watch the tutorial video if you want to hear about it more in depth. So there's really not much more to it than what I said, though. I'll explain how it works. I just don't want to go through in this video. Before this video.
x1 w minus size y1 plus size is y1 size x plus size y1 w size w minus size times 2 1 and c1 index size 6 times 2 size x1 plus size y1 plus h minus size w minus x times 2 1
it's like something like that, right? Around all this, and then it'll work in the same way, okay? That's just me here trying vainly to future-proof my videos against all of the crazy and the very, very cool changes that we're going to be getting in the future. Anyway, yeah, I'll make this as big as I can fit on the screen. Something like that. Pause the video now, get all this copied down, or you can go and watch the before video if you want to hear about it more in depth. It's really not much more to it than what I said, though. I'll explain how it works. I just don't want to go through in this video each one of these line by line, because look at all this. It's all just calculations to get the coordinates in the right places of the rectangle based on where the coordinates are given. Okay, that's literally all this for. Okay, so I'm assuming you've done that. I'm going to make it smaller again, bring back my UI, and close this down. Alright, the next thing we want to do if we're going to be drawing text of any kind is add a font. We don't want to be drawing using just whatever GameMaker's default font is. So I'm going to have to create a new font. I'm going to call it F-Text. This is going to represent the text. The font face I'm going to use for this is M5X7. Oh. I'll do a link to this in the description. I'll put another card thing as well. And if I bring this up to size 36, you can see it's just kind of a simple pixel font made by Daniel Winson or Managor. Makes loads of cool GameMaker stuff, loads of really cool game games, loads of really cool stuff in general. Go check out his work. And this font is freeware, but he does ask for credit, so I'm giving him the credit. Make sure you do too somewhere in the game if you can use this font as well. Okay, I'm not having a habit of size 36 because that's massive. I set size 12 and 10 anti-aliasing off because it's a pixel font. You know, want anti-alias it, we want to be drawing sharp pixels at our very, very fine pixel resolution. And the next thing I'm going to do is make the text object. This object is going to be a blueprint for whenever we want to create a dialog box in the game. We're going to create an instance of the O-text object. Alright, so I'm going to make an object. I'm going to call it O-text. And then before we get started on anything, I'm going to come into our village specifically, not the parent object, the parent room, sorry, go to the instances layer, and just drop in a copy of this, and that's how we're going to test it. That obviously won't be how we use O-text in the final game. We'll probably use a script that will create copies. Okay. Alright, so I'm going to make an object, and I'm going to call it, go to the instances layer, just drop in a copy of this, and that's how. And then I'm going to come into our village specifically, not the parent object, the parent room, sorry, go to the instances. And then before we get started on anything, I'm going to come into our village specifically, not the parent object, the parent room, sorry, go to the instances layer, and just drop in a copy of this, and that's how. Obviously won't be how we use O-text in the final game. We'll probably use a script that will create copies of O-text, create instances of O-text whenever we want to draw a dialog box. But now, just in order to test it, because we can only do so much in one episode, I'm just going to put an instance of this into our village, so it will just spawn text box right away for us. Alright, so back in that object now, O-text will have the create event, as we usually do to start things off, and I'll maximize this and make the font nice and big. The first thing I want to do is establish the coordinates of the text box. So I'm going to do that with an x1, a y1, an x2, and a y2. Alright, it's the simplest way to define the coordinates of a box. Two coordinates essentially, top left and bottom right. The leftmost x coordinate is going to be our resolution width, that number we created earlier, divided by 2, which is going to put it exactly in the center of the screen. And y1 is going to be resolution h minus 70, so 70 pixels up from the bottom of the screen. Most of these coordinates are screen relative and not room relative. That's important for later. We're going to be using the draw GUI event, which draws over to the screen of the game window and not your room. X2, so the far right coordinate, is actually the same as x1 to begin with. Resolution w divided by 2. I'll explain that in a second. The y2, which is our bottommost coordinate, is going to be resolution height. And it's the bottom of our screen, like 180. Now, you might be wondering why this isn't like the far left of the screen, that way it's 0, and why this isn't resolution width, is in the far right. They're both in the middle, so it essentially creates the coordinates of a line on the screen. And what we're going to do is animate the text box to grow out from that position to fill the screen, alright? Meaning that's how our box is going to start, that's the initial coordinate of our box, and to increase the width of that box over time, we're going to have two target coordinates. So x1 target is going to equal 0, that's where x1 is eventually going to end up, alright? And x2 target is going to equal resolution width. That's where x2 is eventually going to end up. A couple more variables going to be in here. The first one is lit progress. As I just said, we're going to animate from being a sort of thin line being a full white rectangle, and lit progress, or linear interpolation progress, is going to be a little bit more than 1, but I'll just how far along we are in that animation. Okay, so at 0, we haven't done it at all, and when this is just 1, we will be at our target coordinates, alright? The next variable is a kind of similar thing, text progress equals 0. Rather than being a percentage, this is actually going to represent the number of characters that we're going to show in our message. So we're going to be increasing this every frame by our global text speed, which is 0.75, and we can change that if the text is called faster or slower. So like three quarters of a character per frame are going to be added to this, not the decimal speed, matter the text speed, only every whole number is actually going to add another character to the message we're going to draw. But basically this is how we're going to create that letter by letter effect, not that typewriter effect if you go slowly building up the message over time. The only other two variables are message, which is going to be the message that we want to draw. It won't, by the end of the game, be determined in the create event of this object. It'll be when we call the script will pass through the message that we want to display, but for now we need something to display. So I'm going to write default message text, and then if we ever see that come up in the game, we'll probably know something's gone wrong because it's not how we'll eventually be determining what the message will be. And finally, background equals 0. Again, won't be determined until eventually, but for now we need to tell the object which background to use for the text box, match which frame of this sprite we're going to use. Alright, 0 is going to be the first one. 0, 1, 2, 3, a lot. The options that we have here. So back in code text now, I can go ahead and add the step event. So I'll method here, add open step, and we're going to progress those two variables that we create to control the animation and the text character build up over time. Okay. First of all, we'll control the animation. So lerp progress plus equal, in order to add to it, open brackets 1 minus lerp progress divided by 50. Okay, that creates kind of a simple tuning effect whereby we start off adding a 50th to lerp progress, and that figure gets smaller and smaller and smaller as we get closer to 1, because again it's going to be between 0 and 1, and when it finally gets to 1, it kind of cancels itself out by doing 1 minus 1 being 0 divided by 50, right? So we're going to go over 1 at the beginning. So we'll like start quite quick and then just sort of slow a little towards the end as the amount it adds gets smaller with every frame. Text progress is going to be a bit simpler. That's just going to be, let me spell it right to begin with. That's just going to be itself plus global.text speed, which is going to add function byte itself every single frame. And now we know what those progress variables are, we can actually compute the results of it. Okay, so our x1 is going to equal lerp open bracket x1 target lerp progress. So if you're not familiar with the lerp function, it takes two values and gives you back a value that is a certain percentage between them. That's the easiest way to think of it. It's just a linear interpolation. Weird way to use it, I guess it kind of makes sense. So the simplest way to think of it is we give it value 1 and value 2, and then a percentage as represented by a number between 0 and 1, and it gives you back a number that is that percentage between those two values. So if this were 0.5, it would give us a number that is 50% of the way between x1 and x1 target. So when it starts at 0, it's basically just going to return the first value, x1. When it gets to 0.5, it'll be halfway between them, and when it gets to 1.0, it'll be x1. If it went over that, if it went all the way to like 2.0, it'll be then like double whatever the distance is between these two, like over the edge, right? It's very, very useful function. You can do a lot of cool things with it, but here we're just making a very simple sort of animation. Alright, and then we're going to do the same thing with x2. So x2 equals lerp, x2 target, lerp progress. Close brackets and next we're going to check to see if the spacebar can press, and if it is and the message is over, we can get rid of the object, which will then move on to the next text object or whatever we want to do then. We'll hold it in adding, but for now we're going to destroy the text object. So if keyboard underscore check underscore press, open bracket vk space, close bracket, open braces, and we won't just always destroy the message if we press the spacebar because we don't know necessarily the player's read it yet or that the whole message is on screen, so we want to at least make sure the message is on the screen before we let the player close it down. So I'm going to get message length with var underscore message length equals string length message, which gets back the length of that message in a number of characters, and then I want to write if text progress greater than or equal to message length, so if we're showing the whole message at some time, instance destroy, open bracket, close bracket, semicolon. Else, open bracket, if text progress greater than 2, if we haven't shown the whole message, but we're pressing space anyway, I'm assuming the user is kind of wanting to skip through the message a bit, so I'm going to accelerate the message by just setting text progress to then equal message length. You don't have to wrap this in if text progress greater than 2 thing, you can just do it whenever, but I like to make sure, this is a very arbitrary amount, but I like to make sure that if you're pressing the very first frame or the couple of frames of the message, that it doesn't do anything that doesn't skip the whole message. So you just have to wait a little bit. I think that helps prevent unwanted presses sometimes. It's a kind of a preferential design thing, up to you really. I like to have it there, so this if this kind of optional. Either way, what you want to do is you want to skip and show the whole message before closing it. You want to write text progress equals message length. Alright, set a product with the default length of the message so it starts showing up. And if you press space plus and row, it will first we'll fill the whole message and then close the message down. Right, just gives us that ability to sort of skip through dialogue nice and quick. Alright, so once you close that bracket, that's everything we need for the step event. That's progress and everything. So all the variables in place, we have all the variables. To calculate the position of the text box and how far on the message is drawn and so on. Now we just need to get to the fun part, which is drawing the result of that. So I'm going to have the draw GUI event. Okay, very specifically the draw GUI event, not the regular draw event. I guess we'll give us a description of draw text box because that's all we're going to do here. And the first thing we're going to do is call that script or that function that we made earlier. So 9 slice box stretch. In yellow, open bracket, you can see from where I've got these down here, so we can see what we need to put into this. That's the sprite of the text box, which is s text box bg, and then the 4 coordinates that we have familiar. So x1, y1, x2, and y2. The last argument that we need to supply the script is the index. That's just the frame, whichever frame that we want to use on here from before. We know what that is familiar. That's what we declared in the create event background equals 0. And we want to change that variable, so we'll just pass through that variable background, close bracket, central. Next, we just want to set our drawing tools up for drawing text. So I'm going to do draw set font to be f text, draw set h-align. The FA center, and for horizontal line, draw set V align, the FA top, draw set color, to be C underscore blank. So draw this for constant assignments. These 4 things you kind of want to do every time you draw text, right? It's very good practice to make sure you call these each time you want to draw text. Try not to just rely on whatever was set before it. It's a very easy way to run problems where you say you set this up in one drawer event and then you made another and the text and it's relying on the fact you set this up in another object. Then you create another object that runs its code in between those 2 objects, and suddenly your last object is drawing text way differently. You don't want to run problems like that. So just with that practice, make sure you call these 4 things before you ever draw any text. Can really help to put these into a script or function. So you can just call one script that you have one called draw slash text, and then you just put like ftext, fa center, and then you put those 4 things in, and it will just call those 4 functions for you. So you can do it in one line. Or a good idea, but you wait to make sure you do those 4 things. So this is what I'm going to draw in black first of all. We're going to draw it like a shadow effect. We'll draw the text twice. Draw it once slightly offset in black, and then once in the correct position in white, so we get a little offset shadow. But before we do that, we have to get the message that we want to display to the screen. So I'm going to type var underscore print. It's going to contain the message that we want to, the final message that we want to draw. And it's going to equal string underscore copy open bracket message 1 text progress. Okay, so this function is string regular, so message is our full message. Index is where we want to start copying from, so we start from the very first character. We have 1, in this case not 0, and then text progress contains the number of characters that we want to copy. Okay, that's the final thing that we pass into this. So we're going to copy a string of message, depending how far along text progress is, and put that string into underscore print, and that's how our text builds up over time. And then finally, we can just draw the text. So draw underscore text, open bracket, and then we just have to do the draw next where we want to draw it. We want to draw it, to keep things simple, just in the center of text box for now. We could look at other things later on for drawing things horizontally, or even drawing things character by character if we want to do fancy effects. That's typically how you do it. You want to know how you create text boxes where like you color individual words or individual words animated and so on. It's a popular thing we want to do, but that requires a lot more work, and it's probably not something we're going to cover in the initial series. So we're just going to draw this whole string for now. The position we're going to draw it is just in the center of the text box, aligned to the top. Right, so top down from the center. So to get center position, we can simply provide x1 plus x2 divided by 2. Right, that's our text box position divided by 2. It gives us the middle. Then the y position is just going to be y1, which is the top of the text box, plus 8, just an arbitrary buffer amount. You might want to put that in like macro or something. You can go here, and just use arbitrary numbers. And we mind hard coding this. We're going to have fairly simple text boxes for this particular game, so I don't mind hard coding a few things. And then finally, the message that we want to print, which is underscore print. Then 1 pixel above that, so the y1 plus 7, we're going to draw the text again, but it's white. So draw, set, color, open bracket c underscore white, put that in draw, text, same coordinates for the x, x1 plus x2, x2, y1 plus 7. You can also try it with like that plus 1 as well if you want to draw it at more of an angle. I'm kind of happy with just having 1 pixel below the text itself. And then obviously again, comma underscore print. Alright, that's everything. There will be a slight problem with this, but I'm going to run it just to demonstrate. Okay, now you see the text message drawn in this tiny box in the drawing. It'll work, the animation work and everything, but you can see it's completely out. It's not, the resolution is off from the game, doesn't match up to anything, and that's because it will look similar, but obviously again, comma underscore print. Alright, that's everything. There will be a slight problem with this, but I'm going to run it to demonstrate. I'm doing now, you see the text message drawn in this tiny box in the drawing. It'll work, the animation work and everything, but you can see it's completely out. It's not, the resolution is off from the game, doesn't match up to anything, and that's because it'll look similar but maybe slightly different on your screen depending on your monitor resolution. But for me, a resolution of 320 by 180 is this amount of space, and when we resize the game window right at the start of the game, what happens is GameMaker sets the application surface, the main surface which everything is drawn, to a resolution equal to the window size, which is a problem for us because our window size is much bigger than our game's actual resolution. So when it comes to actually drawing things like this, we've got way more pixels than we actually want. So I'm going to close this and come to O game and the create event. And just before we go to our new room at the bottom here, I'm going to add the line surface underscore resize. Something a lot of people don't know is that the application surface is just a surface, and you can use the surface functions on it. So I'm going to do surface resize application underscore surface, and set the width and height of the surface to be our resolution. So resolution underscore W and resolution underscore height. Put that to draw. Okay, just see that there. That will set the application surface to be the defined resolutions that we came up with, and not just whatever size the window happens to be when you want it. So we resize that so that we can see a bit better. We've got a small resolution game, but we want to do the window. So by doing that, we keep the size of the surface the same as our target resolution. So if I run the game now, the text box comes up and it's properly sized to our game. You can see if I message text, if I press space, I get rid of it. You can see the animation is working just fine. If I just quickly restart the game, it scrolls up, stops, full nice width, and the text is animating left to right letter. A little bit hard to see because if this is left quite quick, then it's not very long, but if I press space real quick, you can see it skips. Like the drawing box skips over again, if I press it again, it closes it down. Right, okay? So that's obviously where like rolling and stuff when we do that, something we need to do is make it so when we create a text object, loses control. It means I can move around while we've got like a text message on the screen. So obviously we'll avoid that, but that'll probably come in when it comes to creating the scripts that actually create that. as I said, this is a topic that's going to require a couple of episodes, maybe 2, maybe 3, to get the whole system in, and draw a box of any size using a single sprite to determine what it is. there's the containt box stretched, open.
Now, what would the game be about? Depressing stuff. Very depressing stuff.
But for now, we need to tell the object which background to use for the text box, and that's which frame of this sprite we're going to use. Alright, 0 is just going to be the first one. Right? So it's 0, 1, 2, and 3 are the options that we have here. So back in code text now, I can go ahead and add the step event. So I'll put here add open event, step, and we're going to.
Now about to go to sleep soon. Maybe just 5 more minutes.
Progress those two variables that we create to control the animate start effect is going to equal alert, open bracket, x1 target, alert progress. So if you're not familiar with the alert function, it takes two values and gives you backward, makes sense, x2 point. And then when you do the same thing with x2, so message length. So if we're showing the whole message at this point in time, instance destroyed, open bracket, close bracket, etc. Else, open bracket, if text progress greater than 2, if we haven't shown the whole message, but we're pressing space anyway, I'm assuming the user is kind of wanting to skip through the message a bit, so I'm going to accelerate the message by just setting text progress to then equal message length. You don't have to wrap this in an if text progress greater than 2 thing, you could just do it another, but I like to make sure close that bracket, that's everything we need for the step event, that's progress and everything. So all the variables in place, we have all the variables to calculate the position of the text box and how far along the message is called. Central. Next, we just want to that before. It's a very easy way to run problems where if you say you set this up in one drawer event and then you just do the text and it's relying on the fact you set this up in another object. We have fine. The message index is where we want this per character and put that string into underscore frame. And that's how our text built in a drawer. Do fancy for this particular game, so I don't mind what the text again does white. So draw set color, open bracket C underscore white, close bracket draw text, same coordinates for the x1 plus x2, bracket 2, y1 plus 7. You can also try this with like back plus 1 as well if you want to draw it at more of an angle. I'm quite happy with just shadowing 1 pixel below the text itself. And then obviously again, comma underscore frames. Alright, that's everything. There will be a slight problem with this, but I'm going to run it just to demonstrate. Now you see the text message drawn in this tiny box in the corner. It'll work, the animation working and everything. You can see it's completely out, it's not, the resolution is off from the game, it doesn't match up to anything. And that's because it will look similar but maybe slightly different on your screen depending on your monitor resolution. But for me, a resolution of 320 by 180 is this amount of space. And when we resize the game window right at the start of the game, what happens is GameMaker sets the application surface, the main surface which everything is drawn, to a resolution equal to the Windows size, which is a problem for us because our Windows size is much bigger than our game's actual resolution. So when it comes to actually drawing things like this, we've got way more pixels than we actually want. So I'm going to close this and come to code game and the create event. And just before we go to our new room at the bottom here, I'm going to add the line surface underscore resize. Something a lot of people don't know is that the application surface is just a surface, and you can use the surface functions on it. So I'm going to do surface resize application underscore surface, and set the width and height of the surface to be our resolution. So resolution underscore W and resolution underscore H. Performance width, that's design name, left of
Oh, that was loud. That was loud. Samia. Oh, a very familiar name. It feels like one of my secondary school classmates.
But hard to see because if this is better quite quick, and it's not very long, but if I press space real quick, you can see it skips. like the drawing part skips over again. If I press space again, close it down. Right? Okay. So that's obviously where like rolling and stuff don't do that. Something we need to do is so when you get text object, player loses control. That means I can move around while we've got like the text message on the screen. So obviously we want to avoid that. But that'll probably come in when it comes to creating the script that actually creates our message. As I said, this is a topic that's going to require a couple of episodes, maybe 2, maybe 3, to get the whole system in. But hopefully it sounds like this as the starting point. Thanks.
This is supposed to be the top, middle, bottom. Something's not.
Fruit. The height as well. Resolution underscore H180. So if at any point in time we do go insane and we so we want to change the resolution of the game, we can pop into here to replace these figures rather than having to replace them all the way throughout the game, because there's going to be plenty of times where we want to draw something relative to the screen or find a position relative to the screen where knowing these numbers is going to be very, very useful for us. Next up, we will close that and then open OGame and come to the Creator, where we've got a couple of globals set up in here, and then slot one more in between these two, kind of looking at where the variables will be at the top and create a global called text speed instead of to 0.75. In case you didn't know, in a lot of programming languages, actually, you can write a decimal number, like this is 0.75, you don't have to include the zeros, the zeros should apply. If you don't put it there, you put 0.75, just click away right in there, you're just dealing with a number between 0 and 1. That's the only global we need for this particular tutorial, so I'm going to close our game now. And then I'm going to have a script that I'm actually going to import from the already completed project, and I'll explain why in a second. So this script I've got here is called 9slicebox stretch. This might be familiar to some of you if you've watched my tutorial video on creating 9slice boxes. I think the tutorial is called UI boxes / windows or something like that. If you want a really in-depth explanation of this script, you can go watch that video. I'll put like those cards in, and I'll put it in the description as well. But like that video is upwards of 30-minute tutorial, so I wasn't going to go over all of this in this one particular video. In short, what it does though is you can see it takes a bunch of arguments in whenever we call the script for the coordinates of a box. And using those coordinates, it takes an image that you provide it and chops it up into 9 pieces. So the 4 corners, the middle, and 4 edges that will make up that box, stretches out whatever's in the middle to cover the box, draws the 4 corners, and also draws the edges to stretch out to fit the box as well. So we can draw a box of any size using a single sprite to determine what it looks like. Speaking of that single sprite, we need to bring that in. So I'm going to create a new sprite, hit import, and S-Textbox. S-Textbox PG underscore script 4 is one from my assets folder. For those of you making your own, not using my assets, this is what it's like. We've got 4 different types of imaging here, 4 different types of text box we might use throughout. Again, this one here is for like our save slots on the main stars. We've got like selected and unselected, and these 2 are just 2 different types of dialog boxes. This one's like the signposts, and this one's for like dialogue and like messages and NPCs and stuff like that. So you can see if I edit it and if I just bring up a grid, it's always hard to see on just put it 8 by 8. Can be hard to see on the resolution I'm recording this. I'm not sure when the video. But basically, I'll just draw it in real quickly and just controls here. We've got like this kind of grid. Okay, so like taking 4 corner pieces, 4 edge pieces, and middle piece, and we designed this way that these like stretch outward. It has to be quite simple to work with this particular script. If you go watch the other video, I do show how to make a script that uses a lot more patterned ones as well. But basically, these edges here, you have to basically be the same pixels all the way down. So like you're basically designing like this row, and that's about it, because that gets stretched to the full size of the box. Okay, and in the middle, you can't really have anything but solid color, because it takes it up that pixel and just stretches it up the fill to the dialog box. The corners you can do pretty much whatever you want with this. We just draw those as they are. Okay, so this can be a bit more fancy detail if you want to be. Okay, and we also need to name this sprite, of course. So I'm going to call it S-Textbox BG with that capitalization. Origin can stay in the top left, and that's all we need to do with that. One other thing to remark about this script, I believe I mentioned this last episode, but just a reminder for anyone that might be using a future version of GameMaker, because we've all seen some of the changes that have been announced by the games, likely coming to version 2.3 or whatever, I don't know, but whenever it comes, there will probably be changes to the way scripts work. It's possible, even very likely, that arguments will no longer be a thing in the same way, and we'll have to sort of name them specifically per function, and also that scripts will contain functions rather than being functions in their own right, okay? So you might have to end up doing something like function 9slicebox stretch, open the very close curly brace, like something like that, right? Around all this, and then it'll work in the same way, okay? That's just me here trying vainly to future-proof my videos against all of the crazy and the very, very cool changes that we'll be making in the future. Anyway, yeah, I'll make this as big as I can fit on the screen, something like that. Pause the video now, get all this copied down, or you can go and watch the tutorial video if you want to hear kind of more in depth. It's really not much more to it than what I said though. I'll explain how it works. I just don't want to go through in this video each one of these line by line. Because look at all this. It's all just calculations to get the coordinates in the right places of the rectangle based on where the coordinates are given. Again, that's literally all there is to it. Okay, so I'm assuming you've done that. I'm going to make it smaller again, come back to my UI, and close this down. Alright, the next thing we want to do if we're going to be drawing text of any kind is add a font. We don't want to be drawing using just whatever the default font is. So I'm going to create a new font. I'm going to call it F-Text. This is going to represent the text. The font face I'm going to use for this is M5X7. I'll include a link to this in the description. I'll put in a card frame as well. And if I bring this to slide 6, you see it's just kind of a simple pixel font made by Daniel Linson or Manicore. Makes loads of cool gaming stuff, loads of cool game jam games, loads of cool stuff in general. Go check out his work. And the sponsor is freeware, but he does ask for credits, so I'm giving him the credit. Make sure we do too somewhere in the game if we can use this font as well. Okay, I'm not actually going to have it at size 36 because that'd be massive. I set size 12 and I turn anti-aliasing off because it's a pixel font. Anti-alias it when we drawing sharp pixels at our very, very fine pixel resolution. And the next thing I'm going to do is make the text object. This object is going to be the blueprint for whenever we want to create a dialog box in the game. We're going to create an instance of the O-text object. Alright, so I'm going to make a new object. I'm going to call it O-text. And then before we get started, I'm going saying I'm going into our village specifically, not the parent object, the parent room, sorry, go to the instances layer, and just drop in a copy of this, and that's how we're going to test it. Obviously, it won't be how we use O-text in the final game. We'll probably use a script that will create copies of O-text, create instances of O-text whenever we want to draw a dialog box. But for now, in order to test it, because we can only do so much in one episode, I'm just going to put an instance of this into our village, so it'll just spawn text box right away for us. Alright, so back in that object now, O-text will add the create event, as we usually do to start things off, and I'll maximize this, make the font nice and big. The first thing I want to do is establish the coordinates of the text box. So I'm going to do that with an x1, a y1, x2, and a y2. Alright, it's the simplest way to define the coordinates of a box. Two coordinates essentially, top left and the bottom left. The leftmost coordinate is going to be our resolution width, that macro created earlier, divided by 2, which is going to put it exactly in the center of the screen. Y1 is going to be resolution h minus 70, so 70 pixels up from the bottom of the screen. Notice that these coordinates are screen relative and not room relative. That's important for later, because we're going to be using the draw GUI event, which draws relative to the screen or game window and not to your room. X2, so the far right coordinate, is actually going to be the same as X1 to begin with. Resolution W divided by 2. I'll explain that in a second. The Y2, which is our bottommost coordinate, is going to be resolution height. In other words, the bottom of our screen, like 180. Now, you might be wondering why this isn't like the far left of the screen, that way it's 0, and why this isn't resolution width in the far right. They're both in the middle, so it essentially creates the coordinates of a line on the screen. And what we're going to do is animate the text box to grow out from that position to fill the screen. Alright, meaning that's how our box is going to start, that's the initial coordinates of our box, and to increase the width of that box over time, we're going to have two target coordinates. So x1 target is going to equal 0, that's where x1 is eventually going to end up, alright? And x2 target is going to equal resolution width, and that's where x2 is eventually going to end up. A couple more variables we still need in here. The first one is alert progress. As I just said, we're going to animate from being a sort of thin line to being a full wide rectangle, and alert progress, or linear interpolation progress, is going to repeat a number between 0 and 1 that tells us how far along we are in that animation. Okay, so at 0, we haven't done any at all, and when this reaches 1, we will be at our target coordinates, alright? The next variable is a kind of similar thing.
I think so. I'm following his tutorials, step-by-step guide. I have no clue what I'm doing. And my text message looks wacky. Yeah, the text box is kinda long, and I don't know which part of it is causing the issue.
Text progress equals 0. Rather than being a percentage, this is actually going to represent the number of characters that we're going to show in our message. So we're going to be increasing this every frame by our global text speed, which is 0.75 meters, change that to whether the text is scroll faster or slower. So like three quarters of a character per frame can be added to this, not the decimal speed. Now just sort of text speed, only every whole number is actually going to add another character to the message that we're going to draw. But basically this is how we're going to create that letter by letter effect, not a typewriter effect, if you will, slowly build the message over time. The only other two variables are message, which is going to be the message that we want to draw. It won't, by the end of the game, be determined in the create event of this object. It'll be when we call the script, we'll pass through the message that we want to display. But for now, we need something to display. So I'm going to write default message text, and then if we ever see that come up in the game, we'll probably know something's gone wrong because it's not how we'll eventually be determining what the message will be. And finally, background equals 0. Again, won't be determined in the create event, but for now, we need to tell the object which background to use for the text box, and that's which frame of this sprite we're going to use. Right? 0 is going to be the first one. So 0, 1, 2, and 3 are the options that we have here. So back in O-text now, I can go ahead and add the step event. So I'm here, add open event, step, and we're going to progress those two variables that we created called the animation and the text character build-up over time. Okay. First of all, we're called animation, so alert progress plus equal, and we'll add to it. Open brackets 1 minus alert progress divided by 50. Okay, that creates kind of a simple tweening effect whereby we start off adding a 50th to alert progress, and that figure gets smaller and smaller and smaller as we get closer to 1, because again, it's going to be between 0 and 1, and then when it finally gets to 1, it cancels itself out by 1 minus 1, being 0 divided by 50, right? So it'll make it over 1, which is convenient. So it'll like start quite quick and just sort of slow a little towards the end as the amount it adds gets smaller with every frame. Text progress is going to be a bit simpler. That's just going to be, let me start like begin with. That's just going to be itself plus global.text speed. So just going to add 0.75 for itself every single frame, and now we know what those progress variables are, we can actually compute the results of it. So our x1 is going to equal alert, open bracket, x1 target, alert progress. So if you're not familiar with the alert function, it takes two values and gives you back a value that is a certain percentage between them. That's the easiest way to think of it. It's short for linear interpolation. Weird word used for that, but I guess it kind of makes sense. But the simplest way to think of it is we get a value 1 and value 2, and then a percentage as represented by a number between 0 and 1, and it gives you back a number that is that percentage between those two values. So if this were 0.5, it would give us a number that is 50% of the way between x1 and x1 target. So when it starts at 0, it's basically just going to return the first value, x1. When it gets to 2.5, it'll be halfway between them. And when it gets to 1.0, it'll be x1. If it went over that, it went over like 2.0, it'll be like double whatever the distance is between these two, like over the edge, right? It's a very, very useful function. You can do a lot of cool things with it, but here we're just making a very simple sort of animation. Alright, and then we'll do the same thing with x2. So x2 equals alert, x2 target, alert, progress. Close bracket, semicolon. Next we're going to check to see if the spacebar is pressed, and if it is, and the message is over, we can get rid of the object, and we then move on to the next text object or whatever we want to do then. There are a whole bunch of things we might add into it, but now we can store the text object. So if keyboard underscore check underscore press, open bracket vk space, close bracket, open braces. And we won't just always destroy the message if we press the spacebar, because we don't know necessarily the player's read it yet, or that the whole message is on the screen. So we want to at least make sure the message is on the screen before we let the player close it down. So I'm going to get the message length with var and store message length equals string length message, which gets back the length of that message in a number of characters. And then I'm going to write if text progress greater than or equal to message length. So if we're showing the whole message at this point in time, instance destroy. Def text draw set h line df
x1, y1, x2, y2.
a center, that's a horizontal line, draw set v line. Maybe not just to the text, so the line, it's wait call those 4 functions for you, so you can do them one line. Very good idea, but either way, make sure you do those 4 things. So the reason we're going to draw it in black first of all is we're going to draw it like a shadow effect. We'll draw the text twice, draw it once slightly offset in black, and then once in the correct position in white, so we get a little the very first character. We do type 1, in this case not 0, and then text progress contains the number of characters that we want to copy. Again, that's the defining thing to pass into this. So we're going to copy a chunk of message, depending how far along text progress is, and put that string into underscore print. And that's how our text builds up over fancy effects. That's typically how you do it. That requires a lot more work to line to the top of the text box, plus 8, just an arbitrary buffer amount. You might want to put that into like a macro or something. Do it, example windows, and we mind hard coding this. We're going to have very simple text boxes for this particular game, so I don't mind hard coding these things. And then finally, the message that we want to print, which is underscore print. 2, y1 plus 7. You can also try this with like back plus 1 as well if you want to draw a bit more of an angle. But, yeah. Now you see the text message drawer in this tiny box in the column. It all worked, the animation worked and everything.
What the fuck? Why is my text so wacky?
You can see it's completely out, it's not, the resolution is off from the game, doesn't match up with anything. And that's because it looks similar but maybe slightly different on your screen depending on your monitor resolution. But for me, a resolution of 320 by 180 is this amount of space. And when we resize the game window right at the start of the game, what happens is GameMaker sets the application surface, the mean surface which everything is drawn, to a resolution equal to the window size, which is a problem for us because our window size
Okay. Oh, in, undo. Right. Almost there. The corners are missing. Okay, no, but I'm gonna stop here for today. I'll continue this tomorrow.